Good morning, 22nd April 2020. Back to you regarding various issues of management and general management of life, management of profession, and management whatever it is. Human has to do it. Human, which is top entity of universe, who can use mind, who can use logic, is best entity for doing management. But question lies in what actually we are doing. That is very important point. Are we doing rightly what we should do? Are we left honest and sincere in this world? That question is very important. And if you don't do that, honestly, who will do that? That's the point here. We should be clear about our minds. I am a civil engineer, and civil engineer means an engineer who deals with civil projects for public. Civil projects means projects that allow you to stay, to live in your accommodation, in your offices, in your buildings, on road, on railway, on airport, and wherever it is. What I should say, it is a general engineer, an engineer who leads all others. Means it starts with your toilet, it starts with your water supply, it starts your roof. Whatever is not there, that does it. This means project manager which I am talking about is exclusively and entirely different. It is completely different in the sense that we have to be very serious as far as engineering is concerned. We have to understand what life is. Life means not personal life, life means professional life. Professional life, which is an advancement of how we live, how we work. That point is very important. Everybody is living, everybody is working. One living is that I am living for sake of living. One thing is I am living for sake of eating. But one thing is I am living for sake of my mission, for my objective, for my ambition, regarding which I have been sent to earth by my grandfather, my super father, my soul father, and that is God. I don't know who God is, but I feel God is. I don't know what is his name, but I know he is there, she is there, whosoever is. Solar system is an evidence that God is there. Sky is an evidence that God is there. We are living in this body is an evidence that God is there. I am talking to you is an evidence that God is there, because some energy is using this body to talk to you, to interact with you, and giving results, and you are receiving results. So there is no need that evidence must be given. Evidence is already available. My point is different. My management is total management. Just like quality is said total quality, I say total management. Total management, nothing should be left to unknown. Nothing should be left to chance until it applies in technology. Nothing can be left to imagination. Nothing can be left to assumption and presumption. Everything should be clearly answered. That is what professional management is. If I am not sure what shall be the result of that, I should not generalize that until I am sure. Result once, twice, thrice, or any number of times should be known, and then only it will be published. It can be used. If I say no, I doubt, then I should not say I should go on that until I try. Management has been tried many times, in number of times. Management includes, engineering, or engineering includes management. You can know the title of management. I'm not talking. I am talking application of management, application of engineering. Engineering itself is a management. We should know that. Engineering means you have to deliver something. If you say what is engineering actually, application of sciences, known sciences, allied sciences is called engineering. Use of mind, to use natural products in an economic way for welfare of human being is called engineering. Engineering means to take some material which is not usable, make it usable and then use it. It's material, it's human resources, whatever, that is engineering. Means to deliver something which is useful. That is called profession, that is called engineering. Profession is like that. If you know something, if you have learned something, that must be applied first. And if you know only, don't apply, it cannot be called profession, because it cannot be called knowledge actually. Knowledge and profession are related. If you have knowledge, just theoretical, you are not a professional. Until you apply that knowledge and you know what is result, you attain something, you learn something from that, many times, no problem. That is called advancement, that is called profession. So profession doesn't mean sit at home and sleep and have some degree and you call yourself professional. No, that's not acceptable. You may be having whatever highest degree in your life, academic degree, but if you don't use that in your work, don't apply that, or do not modify that, do not update that, do not let it go further, you cannot call yourself professional. Well, my argument is not profession, my argument is from management, because management also includes profession and profession includes management, both are there. If I cannot manage, I cannot be called professional, and if I don't professionalize, I cannot be called manager. I am not talking of a manager who is ordinary manager. I am talking a manager who is engineering manager, who engineers. And engineering invites everything: life engineering, science engineering, social engineering, all discipline engineering, and all kinds of engineering where results are delivered. And where results are not delivered, you cannot call it engineering profession. I am not here to define what it is, but it's easy to understand. It is a must to understand. Whatever we do in our life, it should be useful for something. If it's only imaginary, if it's only for your conscience, it doesn't mean anything. If I want to see world, if I want to improve world, I have to work hard, I have to think hard, I have to use my mind, I have to develop my mind, and only then I can use natural resources, and that's what engineering is all about. We use engineering materials, we call them engineering materials, but these are raw materials, natural products. We take whatever. You make a machine, you make something electronics, you make something like building, you make something, whatever you make, all products are from nature. Nothing is for human. Human itself is from nature, but human is using no natural products for common use. So we have to think differently. We should not go only through what we have been taught in university. We have to think, because mind has been developed. It doesn't matter what degree you have. Thinking does not stop you even if you don't have any degree. A student who thinks, even a primary student who thinks something logical, and that student makes a drawing of that, that's also called production. Because that kid has some imagination in mind. So you are educated one, I am educated one, mind is developed, it has been developed some action, it can be further developed. This mind is an instrument now, this mind is a device now, it can be used just like it's a gadget, electronic gadget. This is also a gadget which should be used by maximum performance. And that use is actually education, that use is profession. If I cannot use this mind, then there is no need of my application of mind, there is no need of my educational value, there is no value, there is no value at all. Means I have to develop use of my mind first, then use it for something. If I can use whatever information I have in mind, whatever source it comes from, I have to use that. If I cannot use that, means I got nothing. That's why it's called earning. Education is earned. It's not simply passed. Earning means this is your wealth. If you can't use this is not earning. It's just a certification. Oh, he is having this. There is no meaning of that. If you do not use that knowledge, you do not use the wealth, and moreover, it doesn't debit anything, it credits you. So is what is education. My management is, I want to use this for humanity, for development of the earth. Earth is in property of God, and I am here, you are, everyone is here to improve it. So we have to improve it. Simple answer. Which religion you belong to doesn't matter. Whom you believe doesn't matter. But if I put my energy, if I invest my energy, my life for improvement of earth, that's my objective, and this has been done. Everybody is doing that. Somebody is doing that small level, somebody is a big level, large level. It has to be done. Otherwise, there is no meaning. Education is a means to develop your brain. Profession and management, and I say management in life. Whatever work you do in your life, that should be quality work. Quality, which we have not understood very well, though we call it quality, quality, and quality. Human has not understood till now what quality is all about. They think quality control, quality testing, quality this, quality that. First, you should be a quality person, that is more important. You used to call character, you may call something else, but I call it quality. You have this quality. You can treat with people very well. You can work hard very well. You can think very well. You can write very well. And you can do whatever is required by you to be done. That is quality in your life. I'm not talking of your family quality, or that's your problem, means how you deal with your family, your sister, your brothers, your members. I'm not talking of that. I'm talking very huge general public. You may work in private sector, you may work in government sector, you may work anywhere in the world. After all, you are dealing with whatever work you do, that is for public. Ultimately, it has to go to public. Source may be different, route may be different. So when you are, and that public is unknown to you many times. You may not know who public is. That would use your delivery. So if something is unknown, it's much better than something is known, because you do not know for whom you are doing. A doctor knows my patient is this one, I am serving this patient. A lawyer knows I am serving this client. So they know nothing. Here we don't know anything. Where my delivery shall go, where my building shall go, I don't know. Yet I work on that one with honesty, sincerity, hard work, dedication, devotion, commitment. All those terms apply there. So I have to be clear in my mind and in my heart what I have to do. It's not for money alone I am doing, it's for some mission. And that mission is to deliver best and best in all respect. That delivery is more important than something else. If I understand that, we understand that we can change this world. Changing world doesn't mean changing earth. It means changing scenario. Change is very important for everything. If there is no change, then there is no life. Life itself is a change. And change is not means change. What do you want? Change means automatic change. And that change is sequential change. Just like we count from 0 to 9, we can say 0 to 1 and then 2 and 3, and sequence goes on increasing automatically. Same way whatever we think it has some result, and that result should be effective one. I have done so many buildings in my life, in supervisory capacity, in executive capacity, or you can say normal capacity. I am not calling it big. I don't want to be very big. It's not question you're big or small. Question is what contribution you have done. What contribution I have done, you have done, or one does. That contribution is more important than what position you had or where did you work. You work here or there, after all you have to work. You have to think and work. You have to hard work. You have to think of and do and work and give quality, and that's most important. So quality of my personality, I know I have to improve that. What I am, I can assess. I can go through my past, present, and what I expect in future, and then I can decide this is my quality. It can be upgraded or downgraded, but I can improve that. So if I can improve my quality by my own thinking, by my own analysis, By own introspection, everybody can do. And if I can do that, you can do that, then it automatically applies onto your work. So, individual quality is important if you want to do good work. In quality means how punctual you are, how regular you are, how do you listen to people, how do you speak to people, how do you attend meetings, how you interact with them, how you interact with public, and how do you interact with your family, with your relations. All that count to quality. What is your talking way, what is your writing way, how do you respect your juniors and seniors, do you respect human being or not? All that count in quality system. If I treat my juniors very badly, I treat my workers very badly, I do not consider a human being, and I am in high position, I don't treat human being as human being, then I am not a quality person. I am a selfish person. I want to use all those without giving them anything. If I am using them, I am getting support from them. It may be human being or it may be resources somewhere else like machines or equipment or material. It's my duty to treat them very well. If not very well, at least to required status, required line. And if I don't do that, then I am not human being. I am only selfish, independent, and I don't care for others. And that's what's not required. Yes, they are workers, they may be juniors, they look to you for help, they expect something from you that you have to know, not necessarily they should come every time to you and demand something. If you cannot understand their demand, then you are not human being, your intelligence is useless. As an intelligent person, as a person in high responsibility, it's the responsibility of that person to assess what actually others expect him to do, and if you can't think that, then you are not eligible for that position. This is what I am saying is development of individual leads to development of good work. If I cannot develop myself, if I cannot train myself, if I cannot control myself, self-control is more important than somebody else controls you. And in responsible position, in supervisory position, in management position, self-control, self-imposition of rules, self-punishment are very important. Why should someone else punish me? Let me punish myself before somebody asks me a question. That is called management. You manage yourself, then you manage others. You can manage yourself only when you have all those qualities of management. Your self-control is more important than something else. If you cannot systemize yourself, nobody will ask you to do this. You have to do yourself. You have to frame your system. That's why I always say, if you join a system or make a system. If you can join a system, means you are not very senior. Okay, you join a system, but when it's an immersion system, you dip in that. You understand that very well, you know what you are doing, then you can amend that system and people have trust in you. Otherwise, okay, you follow that system until you are to that level where you can change that system. If you think it's required for change, for better efficiency. Same thing. If I don't have any system, I don't find it somewhere in the organization or wherever, in my life even, I have to organize that system, I have to devise and design that system. That's my capability as an individual, as a professional. Every professional is system organizer. Every professional is system follower. This is up to professional, what professional decides or what an individual decides. If there is a system, you can violate that system. If there is a system, you can follow that system. If there is a system, you can add on to that system. One who can add on that system is called a professional. Because somebody devised that system, that person is also not God. That system is there, but you can change that system to make it more effective, and that's what management is all about. The quality of your quality that counts. You know how to deal with work, how to give best result. That's your way. Means you must do that. And if you can do that, it's fine. Means it doesn't make a difference. So my quality system is that. Quality is not what you think. Quality means what you can do in a best way, that's quality. If you can do that, if you amend that from every aspect, from every angle, that is a requirement. And if you can do to your own, you can do onto your project, onto your work, onto your operations. Why I am calling project and operation? Because project and operations are all different. Operations is used by mechanical engineers, by electrical engineers, by electronics engineers, by IT engineers. Project is used by civil engineers, electrical, mechanical engineers. Project is temporary while operation is permanent, it's regular, it's continuous. And we use with projects generally in our civil engineering profession. Project means there's a defined limit, there's a start time, there's an end time, and there is a scope of work that we deal with, what project is all about. That period is called duration of period, your project duration, and after that project is handed over to those who operate that. There is a difference. This difference must be understood very well. When we start something, work on that and deliver that, and when maintenance period is closed, that project is called finished project. Then there is no project on that work. This automatically is converted to operational one. Operation means those who operate that regularly. For them this is not project but this is routine. It may be forever. Example, power station, railways, airports, all that we construct and deliver. Construct means not simply construction on site. Construction is total work, designing from concept level, initiation level, imagination level to final completion level. That is called project. We be clear about that. Project means we projected something. We projected a scheme. We expose something. We devise something. We will do this. And purpose of that is that it will work as such. This is a mission. This is your mission that this shall act as airport. This shall act as hospital. This will work on that capacity, and we have to take all considerations, whatever involves a project, and that's called project only with some mission. But there is no mission in operation. Only one mission, routine exercise, routine activity, boring one, but that's also responsible. You have to deliver everything, essential service may be called, so whatever it may be called. So project and operations are defined separately. What we are doing here is project, because project changes everything. Project can be smallest one, project can be biggest one, largest one. It changes life drastically. It changes life very drastically in every aspect. It enhances status. It gives a quality of life. It says that we guard this, safety, our security and investment, all are there. But how people use that, that's most important. Abuse can be done, use can be done, but which should be, if you need a project which can be changeable, then you have to think that way. Means you should not stick to one thing, you should think from many aspects about that. There are various types of projects in our life, civil projects. Though it is every project is civil project because that is used by other professions. That's why interactive disciplines are nowadays named. Means exclusively no project is civil, electrical, mechanical. All are interdisciplinary projects. There was a time in past history when there was a well, we have to excavate well, we have to excavate something, then tube well came. We have to just make a wall or compound wall, or we have to make a small house with stone masonry. That time there was nothing as such other than stones. So those projects were different. There your masons were adequately competent to do as a complete job. There was no education of engineering or something else, architecture. All were by mind, by heart, used materials and built. So in their minds there was some education which we could not realize, and that education not for that much. Everybody got something from God. When you come to this earth, you got something from there, and that's God's university education. Now we are talking about our education. So my talk means I am talking about quality system, and quality system relates to work system, and work relates to design system. Every system is linked to that. So my quality applies from initial stages, or you can say imaginary stages, to final delivery, including maintenance. That is my quality. Every stage should be quality one. I cannot simply say on site, if I work in quality, that's fine. No, it's not on site, it should be on design, and before that should be on budget. If budget is defective, project cannot be completed. We have to be very clear about that. If theory is wrong, work will be wrong. If person is wrong, he shall do wrong work. So my consideration is, my point of view of this differently. You can say it's on a higher level, want to say. It's not the same level as books say. I'm not concerned with books say, I'm concerned with experience. My experience says, don't keep yourself in isolation. Keep yourself in integration with all others. If you can integrate with all activities in project, you will be, you can say, best coordinator. You can relate each one to you, and you can relate yourself to them. That's very important. I have shown you many photos. Let me see, my mobile is charged. I have shown you many photos. Who is there? Let me see. Welcome, Mr. Danish. Mr. Danish, John Danish, Kolkata. Oh, good, very good. Okay. Uh, Let me see what is there. In fact, I wanted some photographs in, and this 91%. So I can continue on that. Applications and files, and this is here. So I'll show you some photographs regarding the project, and I cannot it is like this. I have to come back here. All right. Now you can see this. I'll show you some project here. Various photograph I'll show you regarding this is I'm showing details of some hospital. One by one I'll show you all details here. It will take some time. I can go back again. It's a standard wall. This actually is located in Jeddah, this project. That photograph I am showing. Let's say this is a view of a hospital building under construction. You can see this wall is showing you something. Now I will show you. You can see that. From this stand, this is a under construction building of a hospital. Landscape is not started, this building is in construction, and you can see behind is a tower type higher building that lets OPD. I'll show you also this. Let's see. Actually, yesterday I discovered this photograph so very hard, and this is you can see it closely. Various buildings in this project. I will show you many photographs first. Kidney building, this is. There are various buildings in this. This is kidney building, OPD building, operation theatre buildings, and service building, underground utilities. Various are there. Various buildings are there. I would like to show you as many as possible. This is another part of that. You can see there is no finishing yet. Just everything is seen in construction stage. Some is under finishing item, some is under construction. Various buildings are there. You see, this is the main portion of that building, hospital. level from different angle. You can see entry here, full entry. This building just structurally finished. Let's see another view of that. People are just interested in walking here and there. Is it from a little distance? Distance is back side. And here little better sketch from left end of this building. This entry here, you can see the front entry. Okay, some surrounds here. The internal part of this building, internal portion, some internal area corridor in this. Different type of floors, designs are there. On both sides are rooms, medical rooms. Let's see internal inside of wall of room. You can see the electrical points as well. You can see also a sketch. So different some designs here and down the floor. shift from that corridor. You see another glimpse. This is a closed door of gallery corridor. And some areas on left on the construction hall. Oh, this is a glimpse of roof you see here. Video units you will find here where units are captive, small units and many other units regarding services of building. Similarly, you can see here. This is surrounding area and also one part of roof. The roof and the surrounding area. You can see various piping, ducting, etc. for services. See, there's another glimpse. This was very old build project, means it had already finished 5 years but not completed. There were so much problems on this project. This also, there's so many photos I'm showing to you because this was very problematic hospital project, and this actually must have been completed by now. I'm showing these photographs of 2010 because I did not disclose this because it was under construction. I don't know it's finished now, already it's 10 years more, so warranty period is over. So I can disclose that. Sorry, sir. Alarm. So these roof services are there, chiller service, other services, actual plinths are there. These are also, very badly done. You can see the color of these pipes. It's all looks very old, and items are new, but okay. This is the building here. Same. There are 5, 6 buildings. I'm trying to show OPD building. This is also a view of same hospital building. Another view. Fitness center, right? Fitness center. And this is the landscape not yet started. This is a remote surrounding view, open area view. This is, you can see, the distance from the distance is well. A certain hostel area, that side. There is service building area connect to underground tunnels. I am showing you selected sketch only, not all. You can see I'm just trying to show some various views only. Explanation is different because you see how some work is being done on site. Some cutting. You see the repetition should be there in repetition or not. Let me see. I'll show all of them later on maybe because there's so many more and I cannot. I'll show you only one glimpse of how uncontrolled work. See, site is not at all tidy. Nobody cares. You see how site is. Site is means you can say something installed. It's not completed. Actually, this is my observation. I had disputes, many disputes with many people. You can see even how status of this work at that time. You see, it looks as if 5-10 years old work and nobody is attempting on that to complete that. You can see even scaffolding status how it is. See how it is. No system, nothing. Just do leave and do and let go. And I'm just telling you on this project 75 engineers had changed hands, 75 managers in 5 years. I'll show you some other photographs if I can now because then later on I'll show you because my mobile fell otherwise discharged by that time. Okay, let's start. Who is here? Welcome, Mr. Engineer Amit, that is here. Welcome, Mr. Ram Kumar, welcome. What is this? You had talked about single casting of tabletop compressor foundation. In one of your lecture, I wanted to know about single pouring concrete. Oh, very good, very good, very good. All right, no problem. Because Amit was at this. Amit says, was it because vibrators later on lead to micro cracking? Like, and then so you wanted to avoid joints. Well, I think this is some miscommunication in this case. Well, let us see what to do. I'd like to welcome all again. There's a major question from Engineer Amit Dutt, who is known to me. His question is regarding tabletop construction. First off, we have to understand tabletop is actually it's a foundation for a heavy machine, and in our cases, compressors. I constructed 3 compressor foundations, and these are cracked gas compressor, propane ethane gas compressors. There's 3 elements in that. One is foundation, that's called massive block, real foundation. Other one is major columns, is thick columns elements, and also there is frame on top, that's called tabletop. So 3 combinations are there: foundation, column structure, and tabletop, that is top frame on which your compressor rests or machine rests on bearings, which is later on, that gap is later on grouted by epoxy grouting. Now question is here, single casting. Actually single casting for all these 3 elements: casting of foundation, which is a massive block, casting of columns, which are thick and thin elements, and casting of your beams, which is not massive block. In drawing, this beams or tabletop was designed in many sections to be casted. I had objected to that. This design was from England. I said, no, I don't accept this. Why to cast in different sections when one monolithic casting is preferred engineering? Foundation massive block was about 500 cubic meters. It was to be cast in one go. And because depth is about 2 meters, length is very much and width is also very much. 500 cubic meters means we have to cast in one go. There's no other way because this is a massive block, means machine foundation. Requirement is that in a concreting there are two considerations. Number one is that it should be, joint should be hot. Cold joints are not permitted. This is engineering technology. And there should be no flash setting. These 2 points are very important. Number one is cold joint avoiding. This is a must. If you don't avoid cold joints, your concrete does not meet together with old and new one. There's a gap, say half an hour. When concrete starts setting in, or 1 hour, say, we have to repeat concrete pouring on previous pour within this period. Otherwise, joints shall be non-technical, you can say, non-engineering, you can say, non-working according to requirement. A question here is, number one, you had talked about single casting of tabletop compressor foundation. In one of your lecture, I wanted to know about a single pouring concrete. Was it because vibrations later on leads to micro cracking? So you wanted to avoid joints. Alright. So question is actually very simple, it's not very difficult. This question is about beams, but I am explaining for all, not only beams only. I have showed you drawings, and foundation has to be cast in one go, but we have to be prepared with construction joint in case of some problem. Batching plant fails or something happens when there's no other way, you can't mix on site, there's so much quantity. So you have to be ready with every damping because it is very big element. And this, but success, it is done success when you get 35 cubic meter per hour from one batching mixer, and if you have 2 batching mixers or 3 batching mixers in same batching plant, and you are having 10 or 15 mixers or transfer or trucks, 10 trucks even with a gap of 5, the frequency of 5 minutes or 10 minutes, it's not a major problem for pouring. The problem is how to pour. That's the point. I had shown you a plan of that. In that same one plan was that I had drawn sketch. This is a pouring plan and this is elevation. To section. Let us say width wise we make strips on that 25 meter length or whatever, 2 meters width or 2.5 meters width. And then in vertical you see this is 40 centimeter sections or 30 sections. Let's say 5 or 6 or 7 layers. So 6 layers are there, and let us say 20 layers this way, or 10 layers is 10 into 6. 10 into 6, 60 layers are there. You have to lay 60 layers. Means you have to just fix sequences 1, 2, 3, 4, 5 like that. Depending upon your, it should go in angle, at 30 to 45 degrees angle. If you just in that diagram see how you can fix one layer, then third layer, then fifth layer, again coming to fourth like this. Because it is, you have to vibrate also, keep in mind. Without vibration you cannot do it. So it should not be far apart, just adjacent or other. Suppose I lay at corner one layer, then lay third layer, then to come to second layer or fifth layer, then come back on to top of the layer. So it should go within same period. You have to fill all this. This is called stamping in general language. It's called stamping. Stamping is, it's not a technical term. It's term generated by foreman on that. Let us assume it is stamping. Stamping is done keeping in view temperature control, which is 24 degrees maximum in case of massive block. Because this is GGBS concrete, generally it is done 70% replacement. GGBS concrete. GGBS means GGBS is because a supplementary cementing material which replaces OPC or SRC. SRC is not used these days. OPC is not acceptable. So there is a material called PFA, GGBS and microscope. These three materials are supplementary cementing materials. If you use PFA, there is a limit on that. You cannot go beyond that. We have no liberty on PFA according to engineering. We have to accept that sequence. But in GGBS, there is a, you can say there is a liberty. You can grind it to whatever fineness, as much as fineness matters, and there is no water effect on the water cement ratio effect on the. But in PFA you can say water, but that's not only criteria. Question is GGBS gives you a better control. It gives you better longevity. You can say better polygenetic action. Temperature control, because a massive block requires maximum 24 degrees, not more than that, while normal concrete requires how much? Up to 32 degrees Celsius. So 5 degrees to 24 degrees is not major variation, keeping in view temperature of weather. Because we are doing GGBS, so this is low shrinking element, polygenetic action, and this prevents immediate cracking, thermal cracking, and because we are going to do thermal curing on that, not water curing, it solves the problem. Now you may ask, what's thermal curing? Thermal curing is a replacement of water curing, because massive block cannot be cured by flooding water. Even if you flood water, it won't succeed. Sides are these which are formed one, so there will be no leakage from there. There is no evaporation from that side until temperature is in limits. If you take temperature outside of form, you will know what 10 degrees or 15 degrees or 20 degrees means. If it is more, you have to apply cold method there also. You may spray water on that sides. But question is unformed surface from top, where there is a chance of evaporation. Whole top is free, so evaporation is a must. That's what we are saying. We don't want evaporation there. We want to control and combat that evaporation. We want that thermal energy to stay within. That thermal energy produced by cement reaction must stay within concrete, should not go outside. That procedure we have to make in such a way that let us say we spread a layer of sand on that, we spread a layer of thermocol, or you can say polystyrene, and or you can say polythene, and cover it and just keep it cold, so evaporation will be prohibited. It shall not go away. And outside you can keep cold by spraying water or something. So heat energy generated remains inside, and when heat energy is not released, there is no need of additional water. So it is called thermal curing, which is done generally for massive blocks. Now question is about tabletop. Tabletop was designed, I saw design, I agree with design, that's fine. This beam, complete deep beams around the framing is there, that's fine, structural is fine, and resting on major columns, they are about 1.5 meter by 1.5 meter to 8 meters. So dimension is more than 0.8 meters. So this is also thick elements. If you take quantity of that, this may be more than 8 cubic meters. So you may say it's a massive also, no problem. And it's having your steel plates with angle tanks and all this. That's fine. Column pouring has to go in one go. It's not a major problem. 1.5 meter or 1.25 meter even size, it doesn't cause any problem as well. Even if you cast 10 meters, depending on what fiber, in layers you have to cast, means every 40 centimeters you have to cast. So column is not a major issue. Issue is on top, because drawing showed it in 3 sections, 4 sections. You have to pour this section first, you have to pour that section first. When this was complicated, unusually not constructible arrangement, not buildable, the engineer designer did not think that this is buildable or not, just design his way. I objected that. I wrote to them, this is not going to work. This is not possible. You are going to cast this section for what's meaning, what's criteria behind that. I to the structure, no, because they have done it, so okay, fine. No, you write to them, what is going to be done. If somebody does mistake, we will accept that. If it's possible to cast monolith, means monolith is best. Why you want to say? It's not very big quantity, it's beam only. It doesn't have an expansion joint something. Why don't you cast one? That's problem. Why are you putting sheets there, here, and okay, you want to put sheets there? It's going to cause problem for reinforcement fixing itself. How so complicated reinforcement is existing in the design, and why you want a section? Reason here, give me a section, give me a reason for that. There was no reason. Well, later on they removed that custom joint and they cast in one go. Means sometimes you copy paste and give, okay, you did on some project, doesn't mean you do here. Something design should be based on logic. How do you say that you do it because it is done? Okay, I object, give me answer first. We raise engineering query. Give me answer, why do you want this? What's it? Why, if you want on this tabletop, these 4 sections, why did you do one go in foundation, which is much more than this, which is 500 cubic meter? You want to do, okay, why did you make sections in that? And so later on, they accept very quickly without even saying that. That's the beauty of these people. They accept, they don't give the reason, okay, change. Okay, revised drawing has come. What to do? This is our answer. They change that one. The question is, we have to see constructability, which is much more important than designability. You can do any type of design, nobody stops you, but design should be workable. If design is not workable, your design is rubbish, simply. You may have spent a lot of time on design, but if design is not understood by foremen, if it's not understood by site engineer, and even if they understand, they can't do it, then what is the meaning of design? It's not beautiful. I don't need complications on that. I have seen designs which are doing 32 mm dia bar, 25 mm dia bar and overlapped. What does it mean? Don't you understand problem on site? Until designer understands problem on site, that designer cannot deliver you best design. Design should be done keeping abreast what happens on site. If that is not done, if you don't give full information, what layman has to do, what's meaning of design? We have to vibrate, we have to pour that. Pouring itself is a problem in some cases, because, and they don't even specify many requirements. People just imagine themselves, take themselves whatever knowledge one has, because who can write every time to designer, clarify and clarify. I am not blaming designer here. Blaming is experience they don't have. Required experience on site they don't have. That is a problem. You can design keeping in only theory, it's not design, it's learning. Better talk to site people if you don't have experience, and if you cannot talk to, go to site and see how work is done. There are problems on site. Those problems site will solve themselves, because who has time? Everybody is pushing project. We don't have time. They change details sometimes, which is not correct, I understand. But those people cannot think, even they cheat their own engineers on site. And they do. It happens. So question is, placement of concrete comfortably, constructively should be logical. Sometimes what happens? They give heights that cost 4 meters, but they give a slender design. Why you are giving slender section when height is more? Give comfortable section. Generally architects do that. I am just blaming. Okay, section 30 centimeter, not even 30 centimeter, 23 centimeter, 22 centimeters. What is it? How can we pour that? Keeping column cover, you can say 4 centimeter this side, 4 centimeter this side. What is balance there? 4 and 4, 8 have gone already. Out of 22, 8 has gone 14. 14 only, then you can say rings. What's a space between steel bars? All these points we have to understand. Without constructability, clearly understanding, you cannot design. And of course, this question is raised about this one tabletop. This is very big structures. There were many opportunities to change design. It was changed, but it still was very complicated even then. And moreover, it was going to be applied with epoxy grouting on top in space, another space between base plate of machine to top of that beam. This was to be done. So every care must be taken before deciding something. This is my request. Think before we do something. If concrete is not vibrated properly, it will not work as concrete. If it's not placed properly, it will not reach everywhere. Even sometimes we vibrate, but there is a void. Why? You have to think of that. I asked many people, engineers, about why don't you take GGBs into consideration. There is no right answer. Okay, PFE is sometimes available in bags only, but if something can benefit us, why don't we use that? Okay, let us take this question of microsilica, silica fumes, which is generally used maximum to 9%. It's very expensive material. There are benefits also if you use that. But benefits can be understood if you go to the literature of that, catalog of that, or you see on site how you do it. It's a suspending material. You know that? It keeps cement particles in suspension even after mixing. That is beauty of microsilica. microsilica particles or silica fumes which coat onto surface of cement particles, and until it is vibrated, these do not disbond. So that even if you lay microsilica concrete mix, it will not work until these bonds are broken. This is basic phenomenon that it doesn't work for GGBS like that, because GGBS is different material. GGBS is environmentally friendly. It gives you benefit of carbon dioxide reduction when it works. The microsilica has many other properties. It can enhance your setting time. You can keep it for many hours. It will remain as it is. Means this is different approach, but both are better in corrosion resistant, in sulfate resistant. That is advantage of these. Microsilica percent very little, but GGBS can be replaced even up to 70%. You can replace OPC, and you can replace OPC to an extent of 70%. One bag of cement, that is 50 kg, releases 45 kg or 46 kg of carbon dioxide. One bag of cement, which is 50 kg, releases 46 kg carbon dioxide after reaction. Have you heard of this? If you use this GGBS, it will come to one fifth only. So 80% reduction of carbon dioxide is achieved if you use GGBS. But whom can you ask? I visited one site as third party. I asked that engineer who was my partner, what cement you are using? Project is completed, Structure is nearly completed, 60% complete. We are using OPC. My question was, why you are OPC? What's the reason you are? No, because it is a specification. It's already. Why raise questions? Oh, not question. Why raising questions? I did not go to that site till then. My question was, which world you are living in? Which world you are living in? OPC. You are engineer, manager engineer. Engineer. You are engineers. And you are accepting, even your IIT professor who is a proof checker, he did not raise this point. Now who will raise this point? Prime Minister or President or scientist? Who will raise this point? You are just following what is written. There is no need checking anything. There is no need innovating anything. You are not exponential person. You are just a layman or you are an engineer. I did not say that, but my thought is that if you cannot think, there is no meaning of your being engineer. Engineer means think first and then do, not do otherwise. This is my concept. If I cannot think, I am not engineer, because engineer itself means think. In Jain, who is a genius is engineer. If you are not genius, you are not engineer. You are only engineer certified. That's it. Question is, if we can do something, it can be done in other countries, why don't you follow it? There are also engineers. I was there in 2002, I think. No, 2000. I did that foundation. 2000, 20 years back. Still you are thinking? There maybe have come. I did not go after 2011 to overseas. Still here. I don't know, many changes could be there. And microsilica I used in 1996. I used microsilica there in Doha. It means whole. Something coming here up to 30 years, 25 years. And still you are thinking. Why do you think so much? If you think in time. Don't think after 20 years. So we are, in our country, millions of cement bags are used. Millions. They say we are using 25% or 20% or 15% PFA. Okay, you are using PFA, that is automatic in that industry. It gives you some setting time, that's all. But you are seeing cracks in these beams, you are seeing cracks on these slabs, and you are seeing these hard, cold joints. I ask questions about quality person. What are these? You see, why this different color here? Why are these joints like this? He had no answer. These are all cold joints. Voids, honeycombing. So what is purpose of quality and site people if they cannot look on those items, on those defects which are seen, but they just cover with some gunny bag or some ration bag so that somebody should not see? Why do you hide something? You are doing pre-tension, post-tension. These cables, tendons, and it's not working. It's cracking. Because already cracks are there. It will do further cracks when you strengthen that, you tighten that. What's purpose? You should have explanation. This structure will not behave, will not conduct, will not be durable. If it's already cracks, how can it be durable? And there's no way to solve it. How much can you inject? Means I am not criticizing their work. I am just saying, why don't you take precautionary measure when you design, when you specify something? It's not part of design actually, it's specification. You are writing, use this ordinary cement with this percentage of PF. That's general specification. But why don't you specify use GGBS? Slag is slag not available. That gas is not available. It's not available here. It's available in other countries. How do you say it's not available? If you replace 70%, you will first save. You will first stop cracking automatically, because this is low shrinkage material. Of course, it takes 2 or 3 days more for its striking time of shutters. No problem, we can digest 2 or 3 days. It doesn't matter. But 28 days strength is same. Its long term strength is same, and it adds to durability of concrete. It adds to, you can say, impermeability of concrete, because cracks are absent. It's well compacted, and also you can say it's a kind of corrosion inhibitor if it is properly done. Sulfate resistant it is. There are so many products. You go through GGBS, you will find that. I cannot explain everything because I'm not also fully known of that. I'm just telling you superficially what I got. But it's better, of course. It's first of all qualifies temperature. Differential temperature it qualifies. Forget isolated temperature. When you use this massive foundation, we used to see what a difference in temperatures within concrete itself, means at first layer or third layer or fourth layer. Is it not much more than expected? Because too much thermal gradient is also not expected. It should be within limits. So external temperature, internal temperature, at least for 1 week must be ensured, and after that it's not a big problem. So this was not only in this, I did long back in Libya, though at that time there was no technology. I also did not know about that. I did generator foundations there, which is also machine foundation, but that time there is no such GGBS or all that. We had to at that time I had to do based on whatever available. That technology was not able. So I did old technology, but there was no crawling issue in that, because there were many pockets, or you can say many bolt voids in that. Templates were, concrete was left. It was not completely done where bolts had to come. I put water in that, completely filled all time, so the water could travel into concrete. So you get my point where I'm saying there were so many pockets for bolts, deep pockets. I filled after concrete was done with water into them. So internally 1 meter down water was, and there were all over that foundation. These pockets existed. So water could reach all parts of that foundation. So if water can reach all parts of that concrete, of course within certain limits, and of course Libya was not very hot. It was already 30 degrees, maximum 35. So if you take 30 degrees, it doesn't make much difference as far as ambient 30, and when you put water in that, it shall certainly 15 degrees or maximum 20 degrees. So which is acceptable in terms of curing, because excessive temperature is difficult. If 10 degrees, 15 degrees, 20 degrees, it works in a professional way. And I did not find any cracking on that, though it was OPC. We mixed on site. I did not take from any other one. There was no RMC. It was some other company. Our company had to do. I mixed on myself on site using calibrated mixer, and we produced that foundation very well. French guy came who sent the design. SACM it was. They came and he checked everything, examined, inspected on site. He asked many questions. So there is no question of my praising or sense on that. So is work requires your attention. If you think a little, you can do a lot. 1 minute thinking helps you 2 hours. Because civil engineering means common sense. It's not book sense. Book is something, but book is not everything. What you do on site, you have to do. In country like Libya, where there was not even a nail available that time, I'm talking of 1983, there was nothing there. So sometimes we had to struggle for nails. How can you expect then all these chemicals there? Water we had to produce a well, well like India we had to use wells. I had to take water from that well through our tankers. In those days, and our Libyan managers, you take more and more if you require, because sometimes we don't, it means such a country where material is not available and you have to work, and they don't understand anything, these Libyans. They are all government service, government company. You have so many people, this is the result, you are not doing result. They talk like this. You have so many people, you are sleeping, you are not working. They call it sleeping because they want work. You have so many people, they don't understand what these people are. They are masons, they are carpenters, all are same. We don't know, use them. Every country has different tendency, different type of concept. Means what you find in Gulf, you can't find there in Middle East. What I find in our country, you can't find there. You have to handle these people. Therefore, material also same. Some consultant is very strong, some site is very strong. It depends. Some project is good. If you consider buildings now, forget this massive foundation, this block. Building is it looks very easy. If you construct a building, it looks very easy. Oh, it's building only. What is this? But if you enter into drawings, you will find so many drawings, you are confused as a new person. Architectural drawing, structural drawing, services drawing, schematic, electrical, schematic, mechanical, schematic, plumbing, schematic this and that and that and that. And now CCTV, SCADA and all that. You will find many hundreds drawing. And you are, so how can I read all this? I have many hundreds drawing in 1981 in Iraq. I installed a tower portion of Dar al-Thawra project. I was not very experienced. I left government job in Delhi. I didn't like that job. I went to that place. And I actually, I am government servant, I am supervising that. It didn't work there. You have to do yourself. I used to sit even up 2 o'clock at night to see those drawings, because I never saw such drawings in my life. Government service, where drawings are, the only contractor knows drawing, engineers know nothing, So I had to understand each drawing, why so many drawings. And big A4 size, A0 size, A1 size, and elephant size sometimes. But without understanding them, you cannot move any inch. How can you move? I learned from there, and then I also was impacted upon by some people, because I did not coordinate. I did not understand what coordination was. You have to understand yourself. With one drawing you cannot make a building. If you, this architectural drawing, as people think here, I'll do this architectural drawing, I'll do, no problem. How can you do it? It happens with me. Somebody comes to me, please make a sketch phase, a drawing for me, this is my plot size. Even the engineers come. Okay, and make it. But tell me, how will you construct this? No problem, we have experts on this. Everywhere in Tamil Nadu says, Kerala says, all this, we have experts here, they can do it. I don't know what is expert is. I didn't find any expert in Delhi, I didn't find any expert somewhere, but they have experts everywhere. Expert these masons are there, who can do Taj Mahal every building, they can make it Taj Mahal. They are so expert. And I'm surprised to see they can do whatever they wish, without any worry, without anything. If your balcony is 6 feet or 6 feet, they just do it. No need of beams, no need of something. And when sags, they put something below. This is expertise. If they put some slabs, some sags, they put another girder there or something. This is expertise. If you call this expertise, fine, then there's no need of engineering. I am not saying something. Question is, it's up to public. Public is not aware of profession. Public is not aware what engineering is. So it's not fault of public, it's fault of engineers. Because they don't tell public what we have to do, what we can do. We are not selling our services. We are just sitting as we are bosses. Come on to us. We have to educate people. That's important. Who will educate them? They know doctor is there. They need doctor. They know advocate is there. They know chartered accountant is there. They know judge is there. But that they don't know engineer is also some entity in this country. They say engineer means government only. They are engineers in government, no other engineers there. This is common concept. If you call I'm a chartered engineer, okay, engineer is also chartered. People say like that. Because they know only chartered engineer, chartered accountant. So I don't say it's fault of people, it's fault of engineering community itself, which means hesitates to educate people. They don't write something about this. They don't introduce themselves. So whose fault is this? There is no servant for engineers in this country who would do for you. Institutions are there, they are sleeping. Simply saying, I can openly say they are only busy in seminars, in conferences, into within themselves. They are not exploring themselves. Until you explore yourself, you cannot impact others. Professional explosion is a must. And otherwise, no use. You are engineer, okay, stay engineer whole life and die. Who knows you? You make a house, they will say, yes, this house is leaking, this roof is leaking, this plumbing is not working. They will talk so many defects, but they won't say what you did on site, how much work you did. They don't know. You worked how many hours on concrete, you worked how many days on one slab. They don't know. They know house is defective. Of course house is defective. So you have to take negative impact rather than welcome my positive impact. So this is natural, because this is technology. People are not exposed to that. They know everything where they are exposed. They know train, they know flight, they know everything airport, because that is known to them. But your services are unknown to them. You are not accessible to public. You are not accessible to public, and public is also not accessible to you. So how can they know? Only way is this. Nowadays a medium, there's internet, there are this Facebook, etc., etc. You can use them for that purpose. At least youth shall know, if not working class, because they don't go to Facebook. Means whatever you can do, but we are not doing. So you have to teach them technology. Technology must reach public, that is important. It must not stay in hands of engineers. And engineers must understand they are for public, whole world public. No, it's not what I am saying here. It's also in other countries also same concept. Oh, he is doing column, that's only engineering. I saw many writings and many all this. Oh, they are doing column work here. Oh, this is only engineering. They are casting some slab. This is only engineering. Behind that, they don't know anything. Somebody talks to me, I have highly profile doctors. You are only doing this is only engineering. Make a building, this engineering. I also made that. Supervise the building. How can you supervise the building? Do you know what is behind that? You explain to them what is behind them. They are surprised. Oh, you consider this also. You find weight of building also. You find this wind load also. You see this also. Then they understand. Okay, I showed many quotes. Someone, this also. They think tests are done only in medical. I told them, you are taking X-rays and then treating, but we are making X-rays ourselves. We make drawings or X-rays. What are these? If there is no drawing, you can't construct a building. Point is, we have to be with people. If we are not with people, we can't serve them. Building is not very easy to design and construct. It's whole science, applied science, but it depends on individual. A building can be done by rubbish person or by a professional. There shall be difference. But rubbish person would guarantee everything, and professional would not guarantee anything. That's the difference. If you talk to a layman mason, can you do this? Yes, he will say, I will guarantee. He can guarantee in verbatim, guarantees everything, but he knows nothing. I am not blaming that, because that is mason. That is his foreman. He has to earn money. He has to make his living. But money earning is not my mission. My mission is quality with quantity. That is mission. That is quality. If you just are interested in quantity and no quality, then quantity is zero. Quantity means with quality, with performance, with value. And with value is far away. Give quality at least. Engineering is meaningful only when we deliver that. Otherwise, it's not. It's nothing. What is difference between layman and myself? If I don't do that, I am also layman. I am also mason. Mason can do at least plaster and brickwork. I can't do that. If I am sold like this, I move with the stream, I move just because some builder or some promoter wants to make money, I am an agency in that case to help him make money, then I am not engineer. Then I am born to help that promoter. I am to help that corrupt person who is in power. Is my engineering for that purpose? I did not learn as such. I learned engineering overseas. Of course, I cannot say that 100% they are right, but they are much better than what we are. That's the point. They are not 100% right, I can't say that, but they are much better than what we are. Our approach is not acceptable what we have. Our professors are not practically oriented. They cannot teach a student life. That's very important. Our university professors are only teachers they are. They are not making professionals. With due regard I am telling, our universities are producing engineers only for namesake, not for profession. They have to stay in profession for at least 5 years to understand something. Even if they don't understand, for 10 years they can't understand. But if you can go to site and learn, but they are, because highly qualified, they mind it. Yeah, I learned a lot from foremen. I learned a lot from carpenters, from masons, not only from our country but also from other countries. How they work, how they think. You learn a lot from them and then control them. Because my professor did not teach me that, or that was not part of my syllabus, whatever I can say. Our professors are not technocrats, they are only teachers. Professor means advanced study, but they don't teach you advance. They are confined to theories only. But theories don't work in field, theories work in designs only. So they can make you good design engineer, but not real engineer. I cannot call design engineer an engineer until that person is exposed to work to deliver practical design. I saw many engineers, so I will take economical size of column. Means if you just take in millimeters, so no, I'll take 275 millimeter. Why do you want 275 millimeter? What's wrong is 300 millimeter, or what's wrong is 350? Why don't you be practical? Why you want only cast 1 meter height of column or 1.5 meter height of column? Why don't you cast only directly 4 meter height? What's the problem in that? You take one go is better, or 2 go are better, or 3 go. Which one is better? Why only delaying work? Just erect 4 meter shuttering or 3 meter shuttering and cast it. What's the problem with that? Try to cast even beams with that if it's possible, but that's not practically possible. Concrete is monolithic. It should be as far as possible. If you can do it's fine. Okay, you can do in stages, doesn't matter, but at least element should be cast once. But you also mind by that, the 1 meter shuttering, then 1 meter shuttering, 1.5 meter, or I have seen even 3 stages they cast, when it can be cast in 1 stage. Means there should be a complete understanding of structure. Structure must be understood well, and then construction must be understood. You are neither understanding structure nor understanding construction. Problem is that. And then services. We never think of services at revenue design. And once design is available, structure available, then come in, oh, here is a duct clashed with beam. Why did you not think it before? There is a clash of chilled water pipe with that. There is a clash of lift beam, other beam, here, this and that. So many clashes are there. Clashes would be there. That's coordination. But if a drawing requires 25 clarifications, how can you say that's a drawing? 1 question, okay, 2 question, okay. But for whenever I study something, again raise query. I study something, again raise query. On one project, I raise thousands queries, site technical queries, and in addition to engineering queries. You see this drawing, you see that's not building just infrastructure or utilities. Manholes. What is manhole? But so many queries. I had to do manhole work in details. 400, 500 manholes. Each drawing was prepared. Drawing means plan. I'll show you later on those details. Plans, sections, internal elevations, and connections for each manhole. Because clashes appeared. There are so many services on that plant facilities. So many services. Then rainwater manhole, sewerage manhole, this manhole, that manhole, this so much catch basins, soil, and that means you have to coordinate in saying, oh, this is manhole, this is nothing. We will say simply, yes, it is manhole, this is nothing. You see, study, and then you'll find each manhole was raised in query, each manhole, not even a single manhole left. So my say, okay, that is plant facility. I don't blame her. But question comes to you, when it is ordinary work, when it is individual building, why should be there so many problems? So why? And one more problem in our country is that we don't have any records. If I want to start a building, I have a plot. I don't know what's running below. I don't know. There's no record. And if you go to some government department, they won't tell you anything. We don't have any no record. So we don't have any record. I saw here some storm work is going on. Government work, smart city. This is called Faridabad smart city. They are laying storm water system all over the city. It's different type of system. And surprised I'm seeing the design. They are designed. This is they think differently actually. This is storm water they're calling it, but it's not a storm water. It's a reservoir type. Everywhere put some boxes all over road. This side, that side. These boxes of RCC box. Base slab, walls, and then top slab, and just close on both hands and connect it to further system. They are doing that. Well, before they did for sewer, complete 6 feet sewer, say it's 8 feet sewer, 2 pipes they put in there. With sewage is stored in that, just like it's stored in septic. This is on-site septic tank. From there, the tank comes and pump comes and take out. That's all. So what they do, I'm really surprised. I don't understand what do they want. This is engineering or this is robbery? I don't know. RCC box, is it expensive or simple? I don't know what is this. But they are doing here. Nobody knows what they are doing, but they are doing. Water shall stay in that. Rainwater would stay in that box. And then when there's some level, it will go out through holes in that, go out to pipeline outside, and from there you'll go to somewhere else. Now design is very, very extraordinary. Base slab is RCC, walls are RCC, and top slab is RCC, of course with some manholes or somewhere. Water shall be stored in that. This is water retaining structure because it's storm water. First of all, this is RCC, fine, it's acceptable for such a structure. But it is a water retaining structure. It should be designed differently. You know how we design water structures. Stresses are different. We have to use different type of stresses, but they are not thinking that. Okay, I have not seen their design, but I don't object that. Question is, where there is a base slab and there is a wall here, this wall and base slab junction, what we should do? How should we construct this? What engineering sense says? Should we construct monolithically or we construct first this and then this? What do you think? Water retaining system I'm not talking, you can say duct bank. Duct bank, okay, fine. If this duct bank we can do is, there's no water in there, there's electrical ducts. If there's water and you cause this and that, simply this is a plane of weakness. Water shall flow through that joint. Common sense. There's no water tightness. But they're doing. To whom you can tell, I never found any engineer on that site to see. And if you talk to them, they would say something you don't understand. Well, I'm just asking. They are spending crores and crores on that. And I'm sure water is not going to stay in that. It will go out through that joint. Because there is no water bar. Either cast monolithic or use water bar. This is option. You can't cast monolithic due to many reasons. So at least provide PVC water bar or something else so that water does not flow out, and if water flows out through that joint, then purpose of your box is defeated. There is no purpose of this box, because this 1 meter or 1.2 or 1.5 meter water means 1 ton per square meter pressure. Shall it allow water to stay in? But who is there to think? Nobody is to think. I put quality related sketches there. Sketches means photographs from their sites. Quality is so poor, I can't explain. I have put many photographs. I have also shown to you on these talks many photographs. But I think I can behead myself. It's better than to speak to them. I have posted on their Facebook many such snaps, but they are so gentle to public, they remove them. Okay, remove them. It's not my government. You can do whatever you want. It's your choice. But facts can't be hidden. Facts are that we are not quality country. Simple saying. We are not quality professionals. We are only professionals. We can do quality in other countries. We go to GCC countries, we go to Middle East countries, we go to somewhere else. We can work with quality there because we are forced to work with quality. Or there also we want to. There is a force. You are forced to do that and you do that. I learned what is workmanship, what is control in Iraq. Can you believe it? Today, although Iraq is no more now, that Iraq is no more, but at that time, I can say this was number one in controls. Not on papers, on site. They didn't believe in papers. On site they used to do that. And millimeter by millimeter they used to measure column to column spacing. And they used to measure not by theodolite, by manual strengths. How plumps they used to check 1 millimeter variation in 1 meter. 4 meter height column, if it's more than 3 meter you are out, rejected. I want this. And not only this, post concrete also they used to say, is there a deviation? Is there bulging? Coming inside checking. Oh, there's a difference, chip it out or do something as a fair face on problem. You know? That is called control. They wanted to make their country quality wise. But here we can do whatever we want. Sometimes we learn from others. We have to. Because those people want something durable. Why? Okay, it's Iraq. If you go to Arab countries like Qatar, Qatar is also in line to that. I mean to say can't equal to Iraq, but because after that I worked in Libya as well as in Qatar. So I worked in your UAE also. I worked in Saudi as well. I know quality variation how they do. When you forget Qatar, Qatar is something extraordinary was. If you go to, Iraq was extraordinary. If you go to Qatar, it's a British management. Their quality is little substandard to Iraq, I can say. And UAE, if it's oil project, fine, there's something different because oil project is very much controlled and this very minute reasons being pipelining work, which is even sometimes running, even adjusting the foundations, and there is no more deviation. It means you have to comply by that. But in buildings where there's no relation to these infrastructural items, there you can say that something should happen. Here, I don't know because practically I did not work in this country very much, to be very frank. I worked in supervisory category, that in government, and practically when I go to some site, if I supervise, I go. Otherwise, for example, I supervise some house for my sister, for my own house. I was not satisfied because people are used to themselves, they don't want to change. You speak to them, you talk to them, you train them. They can't change. And I have experience of that. But I had to pay extra, I agreed for that. I'll pay extra, you have to do this. If you cannot do that, then sorry, I'll hire someone else. Example, quality say, very small example it is. Maybe I have spoken this many times here, and it is say, is there, let me see, excuse me, Mr. KGM, Mr. Welcome, Mr. KGM. I'll also copy this, otherwise I lose contact now. There was very small item. I was just thinking to start my work of my house. I went to this distributor of steel. I told him that I want this much steel. So okay, this is rate, will get this much. But I asked him, please, I want straight bars. Oh, we'll send you in truck. No, I don't want any bent bar. If you can deliver straight bars through trailer, it's fine, or no. Then he says, we can do, that's not a problem, we'll charge extra for trailer service. Okay, I'll pay you that one, no problem. I got that delivered by, I went to some fabricator, steel fixer, because I wanted to give in contact, okay, who takes borders. That person was available. That gave me rate. This is, I told this 10 mm, 12 mm and 8 mm bars, nothing else. Only some bars of 16 mm. I am going to use all 12 mm bars and 8 mm bars. He says, very expensive. Okay, no problem. I'll pay you. Because higher diameter bar they charge less, and for lesser diameter bar they charge more. This is because of weight they charge. If they are using a smaller diameter 12 mm in beams and 8 mm in slab, means the quantity is less, so they are charging per kilogram. So they are right also, means in higher diameter 25 mm or 20 mm, 16 mm, they get more weightage. So according to their commerce, they are fine, I don't mind that. But I said, tell me, how will you protect my steel? He said, what do you mean? I mean, all your steel I have seen here is rusted. I do not want my steel to be rusted. Do you understand that? No, साहब सब जगह होती है, ऐसी होती है. मैं साफ सुथ तो कहना छोड़ दे. Tell me, but can you do it or not? How can I do it? I told him, I will give you plastic sheets. You have to cover all time. When you have to take out and then cover. And which you fabricate, you cover that also. He didn't agree. I can't do it. He was laughing on that. Okay, you laugh, no problem, I don't mind. You have every right to laugh. If you can do that, tell me, otherwise thank you very much. He didn't agree. Okay, no problem. There are so many other people in this world. You are not alone. What I am saying, people can't change. Now tell me what was problem for him. I am giving plastic. Can't you cover? What's your problem? It's my material. I don't want to spoil my material. It's my money. What is your problem? So I decided to do in my at my home. Finish. I have space, no problem. I'll do myself. Means when I am going to spend so much money, at that time it was 55 rupees per kilogram at that time. 55 rupees per kilogram. Now maybe not that cheap. And I had to use whatever steel, means if I am going to use so many lakhs of rupees on steel, I cannot use few thousands on polythene sheet. How it is, laughable. Means you are responsible for protection of material. If you destroy that in beginning itself, how can you give life to your building? If you are going to use rusted steel, what is purpose of that steel in your concrete? Why don't we think that way? Knowingly that this will damage, still we are using. Go and see all this project, all rusted steel. Go and see all buildings, all rusted steel, and nobody questions. You are putting rust in your steel, in concrete, and you expect durability? How? Why designer does not mention it on drawing? What is role of designer in this case? Designer has got no responsibility to instruct people, to instruct site people that you have to this way. This is a part of design instruction also. Why should I read every time CPW specification? Why should I worry about CPW? I have my own specification. I have my own project specification. You devise this. You are designer. You are a specifier. When you are specifying my details of concrete, my details of steel reinforcement, and this and that, you devise that also. You have to work like this, technically and on technical matters. Forget working methods on site. Is this not a part of design? Okay, this may not be a part of exclusive design, but this may be a part of feed. This may be a part of something else. Who shall do it? Means we are having gaps everywhere. You leave it to side people. Why do you leave it to side people? Who are side people? Side people are on front. They cannot think there. They have to operate. This is operation management. That event has to be operated. That activity has to be operated. There is no way they can't think. They have to comply by schedule. They don't understand anything. You have to instruct them on drawings, and then if they don't do, they are responsible. But now you are responsible. You are neither writing temperature controls, or something else, and you expect the quality is not in line. How can quality be in line? Donkeys work at site, don't forget. I am also donkey when I work at site. Donkey means hard work. When you are standing in sun many hours a day, you cannot think everything. How do you expect that man? He may be a diploma holder, he may be a foreman only, he may be nothing. So, why do you expect that person to do it? Because I have experienced that. Even those people who do not know ABCD of construction, they do on that. They do that. One of my known guy came to me from Gurgaon. He wanted to construct something. He got approved drawing from building department, architect devised, and he came to me. This architect, I have no relation to that person. I have paid him this much, but he wants more money from me. You are my friend. You are engineer. You help me. Okay, no problem. I'll do. He is asking this much more now. I want you to do it. You are there. Why should I pay money then? But I was surprised to see that design. Copy paste. Copy paste. Believe me. And there was a lift. I asked this person, my friend, give me which company lift you are using. I'll talk to that company. I'll take information from them. I not talk to any company. Your drawing says there's a lift in this. And what about foundations? What about soil? I want to see soil. Why you want to see soil? Oh, you don't understand, my friend. This is soil. I want to see how strong it is. No, it's okay. Means this is zone 4. You don't know what is zone 4? No, my contractor says I can do everything. Who's your contractor? He is a person working in Saudi Arab. Okay, but who is he? What is his profession? He is an electrical man. Oh my God. Oh, I break my head. He is an electric man. He is doing building construction. And he told him, I'll put some sand below foundation and seismic problem is over. Such experts we have. Just put some sand below your foundation, and problem of your soil and problem of your earthquake is over. People trust them. They don't trust you. That person, when I ask him, I want to see soil, I want to see this. He said, you are giving me tension. I came here to seek your help, but you are giving me tension. That contract shall run away if I ask all this. You are making building or what? He said, no, I don't want zero defect building. I want just building. If there are so many buildings in that area, if all fail, mine also will. If they die, I will also die. Now what to do? Tell me what is solution to this problem. This means either people are crazy or I am mad. Something is wrong somewhere. Yes, then I can say I am mad. It's not question of money. Question is what actually you are doing. Money is one part. But you should lie to people. You should not tell facts to them. What for you are there? Let them annoy themselves. Let them be under stress. Fact can't be hid. Today I say yes with you, and tomorrow you say you did this wrong and this wrong, and this is happening, this is crack here, that is crack here. This generally happens with me. Because I do not do any job with some company. I try to do my job on my practice, and I have experienced this in my career, that such people are there who do not respect these and forget soil investigation. Forget these architects. They don't understand soil. I experienced that. They don't even go to foundation excavation and see what soil is. They can't even see something there. One architect told me, oh, this is very good clay soil, this is very good soil. इस पे बहुत अच्छी खेती होती है. Bloody fool, you are doing agriculture on this or you are doing founding on this. Yes, they do not understand what they are doing. But they are involving. They involve there, despite knowing nothing. So engineer is defeated everywhere. Either you also act in the same way, you try to speak lies, tell people, okay, you're right, we will do. Yes man, become yes man. Can engineer be yes man? Yes, architect can be. There's a difference between architect and engineer. Major difference. Forget licenses, forget registration. I'm not talking of that. If architect is defective, if architecture is defective, if finishes are defective, if space design is defective, building is not going to collapse. If covered area is defective, everything is defective, building is not going to collapse. But if structure is defective, building is going to collapse. Certain, for sure. That is difference. I don't care about law here. I am going to risk people if building collapses, if it sinks, if overturns, if it is tilted, if it's out of stability. Architect doesn't work there. Nobody asks architect what he has done, because the architect is a beauty parlor, you can say. Means architects make us a bride for one night. That's it. But anatomy, who is responsible for anatomy? Who is responsible for bones and arteries? It is poor engineer who is not valued at all. If my columns are not working, if my beams do not work, if my slab sacks, shall building stay there? If soil is not properly done, it's not properly compacted, it's not properly soil improved, who is responsible? It's not job of architect. Architect knows nothing about that. Knowing superficially doesn't mean you're qualified. Yes, they learn some structural element design, we know. I also learned electrical engineering. I also applied thermodynamics. Am I a mechanical engineer? Am I electrical engineer? No. I also studied social science. Am I social scientist? No. I also studied applied, you can say geology. Am I geologist? No. It has to be understood. It's part of job. It's part of education. So, it is experience. It is expertise that works. This point we must understand, which you do not understand. Long experience is itself a learning. What I am telling you is not in books. Can never be in books, because those who write books, they don't know this. I wrote some book in 96 was published. It was practical book, completely practical book. I started in 92 to 96 to 4 years because of there were many sketches in that which were done manually and without any standard size or dimension, and it took a lot of time to compose that. But that book was only professional, not educational. It didn't work well. I don't mind that, but then this publisher was unhappy with me. So I told him, I have another book. No, I will not take any book from you because your books are not viable, and we need books which only professors write. Okay, commercially that publisher is right. He is there for making money. He says, I am here to sell books. If give me books which your books are not receptive in the market. I know, because we don't read books by professionals. We never read any book. How many engineers write? First question is that they write only notes or papers which are published in journals, and those are not for public. Those are only for engineers, professionals. Book which you write based on experience is not demanded by public, because public is not in field of engineering, and engineers are not used to read books. So even if you write something, it will not work. I experienced this. I wrote lot on structural engineers forum of India. Those designers are not interested at all. They are interested only in limits, bending moment, shear force, deflection, this theory, that software, this and that. This is their world, as if they are living for only software. They don't know anything about that. They are not interested in real engineering, which is complete conception, study of buildings in its comprehensive form. They are just whatever members, each elements and all that. They don't know how performance of building is. That's more important. And in relation to soil mechanics, I have not seen any question in those hundreds of questions I have seen there, but no question of reality. Nobody talks of soil mechanics, nobody talks of rock mechanics and soil investigation and that, or soil mobility, and no, just their soft E-tabs and all that. Okay, it's their world. They just even they don't write, they don't know about profession. This is nature. They are comfortable positioned. They are interested in softwares, sit in office, design and make money. That's all. They are not interested in sites. And without sites, design can't survive. It is site that applies design. It doesn't mean I have a site, I'm just advocating for that. It's not question of advocating. Question is requirement. If your design is not done, your design is nothing. It's rubbish. If I change that on site, I do according to my way, I don't even follow your construction joints, I don't follow anything in that, what shall you do? Building won't fall, certainly. But your design is not welcome there. Because it's difficult to work on design. So I say design should be done with full thought. As question was raised by Engineer Amit, is a very good question. Because confusion exists. Confusion should be clear, concept should be clear. Engineering is vast field. It's not small field. But structure is one part. There are so many other parts. Here I am interested in quality talks, and quality involves everything. It's not one part, it's not other part, it's complete part. And now I was talking about some items other than this question, and that items were, let me check, I was where, because yes, file I'll check me, it was I have actually put checklist on my files, and just setting out and excavation. Then other item was hand excavation, then formation level, then blinding, then concrete protection, then footings, foundations, stub columns, then backfills, and then floating slab. After that RCC column works, then wall works, and then lift well, then it was stair work, then suspended slabs, and then pedestal footings, RC footings, blocks, and RCC for generator, alternator foundation, and then it was structural works and RCC artificial finish works. Then it was Hodi slab, RC sloping portion of slab, and suspended slab works, and then it was RCC heavy compressor foundation, as I explained already. Then it was tabletop columns, and then tabletop works, and then this RC swimming pool already done, and shooting range. I think I was doing something here. I don't exactly remember shooting range work, and before that it was item 26. So below ground RC swimming pool, RCC swimming pool. Okay, 26 basis slab, and it was then 26, 77. Items this is foundation footings. This was now, I think I have done this checklist for foundation footings, concrete pour. This I have done, or I repeat that, I don't remember actually what I talked. Checklist for stub columns, concrete pour. So let us say I repeat just what actually it is. I just read it. Maybe I remember. Checklist for foundation footings, concrete pour. And before that I'll take some water also before going to details. Now, checklist for foundation footings, concrete pour. Item 6, that is preparatory works, is already gone. Now 28, this item is concrete pour. how we are going to pour concrete. Before this, let me read maybe then. Plan adequate number of foundations in one go to meet RMC delivery requirement. I think I've done it. Let's see. Plan adequate number of foundations in one go to meet RMC delivery requirement. Book concrete in advance to facilitate RMC supply to chart out RMC plan schedule. Book concrete pump of required boom length. Have site appraised by RMC representative for assessment of timings. Footings pouring is fast activity, which point has to be considered. Prepare pouring platforms wherever required. Ensure pouring inspection is over and ITP is signed off. Concrete temperature should not exceed 32 degrees Celsius. In hot weather, plan for concrete pouring either in early morning hours or late evening or at night hours. Make sure that the supporting arrangements should not disturb during pour. Make sure vibrators and standby vibrators are available. Make sure masons tools are available. Make sure adequate number of carpenters and steel fixers are in attendance for meeting certain low profile emergency. Make sure all arrangements regarding curing are available. Make sure concrete testing equipments are available either directly or by laboratory. Make sure that these equipment include slump, cone, cube, molds, thermometers, air void measuring instruments, and make sure that a qualified technician is available to test and record all observations. Make sure RMC delivery timings are correctly recorded. Ensure that no RMC truck starts pouring delivery at site without clearance from testing position is given. Make sure that trained group or gang to receive pumped concrete is available at location of concrete. Prior to commence with pouring, have vibrator checked for operations. Make sure that location is cleaned well prior to pouring commences with. Check that concrete location is watered well to avoid flash setting. Receive RMC truck after testing clearance and start pouring from pump station. Receive RMC truck after testing clearance and start pouring from pump station. This is a very critical point because some people ignore this. Don't allow truck to enter site until slump is cleared, temperature is cleared, and your air voids are cleared. Footings can be poured in one go. Should depth not exceed 400 to 450 mm. One go means layer has to be, if it's 1 meter, you cannot pour in one layer. Footings can be continuous in case beams are cast monolithic. Make sure that no starter bars are displaced during pouring. Make sure that concrete occupies all spaces around rebars and forms. Immediately after top of concrete is leveled and say half an hour is over, curing compound could be sprayed depending on site situation and weather temperature. No gaps should be allowed during pouring for a better pour quality. It's common practice not to order last truck since exact quantity of mix is not known. Therefore, hold last truck to replace its order after major pour is over. Make sure that construction joint is correctly formed by roughening or scabbling. Testing technician must collect cube samples and record all testing observations. Apply Asian or gunny rolls and polythene sheet over unformed surfaces and cure with water all times for at least 7 to 10 days depending on weather temperature. Make sure that curing arrangement is not thrown away by fast winds. Hardened concrete should not be allowed to dry anytime till curing is over. Side forms can be removed after 24 hours or 36 hours. This was about ordinary arrangement of ordinary pour of concrete in foundations. And okay, this item that I explained to you, those foundations, this is foundation like it's the independent footings, that's called a spread foundation, or also combined footing. What happens actually when we do some building excavation, maybe building size is bigger, for example say school building, or some of the building where 300 foundations are there, 200 foundations are there, or any number of foundations are there, whatever it is. We do not go one by one. This is not actually practice, and we cannot excavate for each foundation. It is also not convenient professionally. So what we do, if it's we see what type of soil is there, we excavate all area you excavate. Of course, there's a question of backfill later on, but you will save time in excavation, you will save time in your concreting work, and you will save a lot of time which you cannot save otherwise. You can take all excavated material to piles somewhere, and material is not, because it's not allowed safety wise also. So you have to keep that material somewhere, if it's usable, reusable, or you have to dispose of it somewhere else. So we excavate whole area like phosphorus, and then we prepare compaction for that area, and then start your whatever items are required. Then bearing capacity is ensured, which is also mandatory. After that, you do your, if any chemical treatments are required, and then blinding concrete, all that. Question here is, item here is pouring of these footings. Let's say there are 50 footings, 60 footings in one go to pour. I'm not saying all. So we arrange this form work depending on its number of uses. Let us say marine ply, this can be used 18 mm, can be used 5 times or 4 times. Let us say on safer side 4 times. So how many foundations are there? We accordingly say number of foundations this, so we can use this for 4 times. So we decide that as a 50 footings or 60 footings, whatever cubic content is there, and we place order for that. So this is because foundation, this doesn't take much time to pour. And depending on depth also, there's a foundation, independent foundation, combined footings or some other types of footings, 40 centimeter high, 30 centimeter high, 50 centimeter high, depending on that. So if it is within 40 centimeter, means in one layer we can do it because of vibration issue. We cannot vibrate externally, we have to vibrate internally, therefore internal vibrators, needle vibrators are used for that. So all say, let us assume all are ready, everything is ready, and we have to just pour. So what is required in pouring when there is no basement, just the foundation ordinary, say 1 meter deep, 1.25 meter deep? We have to need access to all foundations. That's first requirement. We have to reach to all foundations, because we have to come in and go out, all workers, everything, vibrator, and whatever material is required there. Only benefit is that we have supply of, we have provision of concrete pump with this. Concrete pump is mobile pump that we can station at convenient position so that it reaches to all areas of those foundations. That we have to see by our measurements, or by positioning that pump there, or by let RMC guy assess himself whether the pumps can reach everywhere. Or we can use tower crane as well, but tower crane has limitations. We cannot go for tower crane for every bore. Mobile pump is best if it's available. So what we have to see after inspection, we have to ensure everything is clean. Every location is accessible. People can walk around there without any problem, because when there are 50 or 60 footings, it's not in one location, there are many locations, and we have to shift vibrators from here to there, we have to shift people from here to there, we have to do everything. Sometimes it's cast, sometimes that is cast, sometimes it depends upon our sequence of casting. So we have to be careful then. Depending on that, we have to require concrete quantity deliver at the same time. So we have to say, let us say 200 cubic meter, let us say 300 cubic meter, or 50 or 60 meter, whatever quantity is there, whatsoever quantity is there, we have to place order accordingly, and we have to instruct for foundations. The slump is also maintained in that range. Temperature they know very well, so RMC guy, because they are local people, and we can say that this is pouring time, or when we have pouring time, that temperature we have to ensure, concrete temperature we have to ensure, and we have to ensure that means so let us say 5 degrees to 32 degrees temperature of concrete, and let's say it's early morning, so weather temperature is not big issue. If it's daytime is a question, we generally avoid daytime concrete. It's winter, okay, it's likely, but if summer, we never do concrete after 11 o'clock or 10 o'clock. After that, temperature rises to 40 degrees, and humidity also sometimes more than 90 degrees. So it's up to us means when we want to cast. But we have to be very sequential and serious for that. Application of pour, application of vibration, and then application of curing, and before that finishing all that, we have to take care of this one. That's why all the instructions are written. These are tentative indicative restrictions, but these are also, as I said, about construction joint, the question of construction joint, is it possible at that time you could do it, but sometimes we do, sometimes we don't do. And even if you do by wire, apply wire brush on that, apply something like that, binding wire, some teeth we apply there, it doesn't work very well. Next day we have to see that So that day we cover it by polythene and then we start curing on that. So also this is pouring of concrete in that one, though it is not very difficult, but it is not very easy also, because you have to do it fast, you have to take care of surface, you have to take care of its finishes, you have to take care of you can say vibration, and all that is cared about. And it is foundation, you should not forget. This is only last element that makes building stronger. If footings are not stronger, your slabs, your beams, all that are at risk. So footings must be taken care of seriously. And of course there may be some beams around, you can cast them together or you cast them separate, depends upon your plan. There may be plinth beams or maybe foundation beam, depends, but let us assume here only foundations are cast. So question is, your here I think cold joint issue is not that much, because these are, you can say, independent footings or isolated footings which are cast immediately. If it's 40 centimeter, we cast it, we bring pump boom there and cast whole concrete there, doesn't matter. Yes, until it is more than 40 centimeter, we can pour in two layers, but if it's only one, let us say it's a 50 centimeter, then we have to pour in 30 centimeter, 20 centimeter. But generally I have seen either 40 centimeter or it may be around 1 meter, depends on. So, and moreover we don't keep nowadays this sloped one at top, because that doesn't work. It can't be vibrated well. So just rectangular footings or square footings is only height 40 centimeter. If we do that in ordinary building, is fine, and we have to take later on concrete curing controls. That's what it's all about. And it continues for 7 days, 10 days, 8 days, depending upon requirements. And next day, 48 hours later, after 48 hours, we can take out the shutters, side shutters, and we can continue curing, or we can apply it, we can apply curing compound on that. That's later on. What I see in this item now, it says that. So then we come to item number. This is 7's properties checklist for stub columns. So it's a small item, though it's very important item. The stub columns is columns that are between plinth and foundation. That's called stub, means small columns. And item 29 is concrete pour. So it says plan adequate number of stubs to be poured in one go to meet RMC delivery requirement, because RMC means ready mix concrete, which doesn't feel happy to give you 1 or 2 or 3 cubic meter of concrete, because truck itself is stuck in that case. But sometimes you get also, means not, it depends on what workload they have and what you have, because if you hold transfer mixer for a couple of hours, it doesn't work. Then you can say book concrete in advance to facilitate RMC supplier to chart out RMC plan schedule. Factually, it would be inconvenient for RMC supplier. Too small quantity. Book concrete pump of required boom length in case stubs pour is required by a pump, but stubs may also be done using pumpless pour. Check that stubs are not more than 2 meter high in general. Check that site provided means are feasible for pouring RMC. Check if site pour means are utilized. RMC should not be delayed excessively during pouring. Check that all stubs planned for pouring are safely accessible for pour gang. Make sure masons tools are available, and make sure adequate number of carpenters and steel fixers are in attendance for meeting certain low profile emergency. In case of concrete pump being used, make sure that only required quantity of mix is poured into stub to prevent concrete from dropping around stub. Preparatory works. Ensure vibrator is applied rightly into sub portion without touching reinforcing bars or forms. In case vibrator touches forms, chances of form opening are not acceptable. Check all curing materials required for stubs are available on site, including curing compound. While concrete truck arrives, collect sample for slump, air voids, etc. Check loading and delivery times, and also check RMC dockets. RMC dockets is very important though, means because what time this truck left batching plant and what time did it reach your location, it tells you difference of time, and that is also should I exceed, defined one. That's purpose of checking your docket, and also to see whether mixtures is used or what grade of concrete it is. Allow truck to move into location station for delivery. Check site prepared open chutes are available in case of pumpless concrete so that concrete can be easily transported to stubs. In certain cases, steel wheel barrows can also be used for transporting concrete from trucks. Small buckets can also be used for collection of concrete and pouring into stubs. Mobile or tower crane can also be used for pouring stubs if available. Make sure that stub is concreted in layers not exceeding 400 to 500 mm deep. Make sure that vibrator is efficiently used after layer pouring. Make sure that after pouring stubs to their marked top level, top is covered with polythene or Hessian as convenient. Make sure that no supports are slackened during pouring. While using pumpless pour, there are remote chances of foams opening, but with pumps chances are more. And make sure that foreman or charge hand type supervisors do not allow water to be added to concrete during pouring. It often happens that during long pour and concrete truck getting delayed, concrete stuff is stiffened, causing hardship to workers. To avoid that, they tend to add water to mix, which is not acceptable in any case. Start curing after few hours depending on temperature, but sides of forms externally can be kept cold by spring water. Side forms can be removed after 25 hours to 36 hours, but it takes time while opening. Okay, opening forms due to many reasons. This was general treatment we do to small columns. This is actually normal circumstance I'm talking about, means for small quantity of concrete, because small columns, stub columns do not require major quantity of concrete. Maybe sometimes you need 1 cubic meter, 2 cubic meter, 3 cubic meter, 4 cubic, not maximum more than that. So pump availability is remote, and you get your transit mixer also in busy time. You are lucky. Otherwise, you have to take at night time, and then it is difficult because column quantity is very small. You can say very small cubic meter wise, but you have to deal with that, and with quality also you have to do with. That's purpose of taking this item, because first of all is opening of site. If you do not use the crane, or you don't use pump, then you have to use either bucket or something with controlled controlled drop, and that way you can do no harm as far as you follow technology. It doesn't matter. And sometimes even using your pump, concrete drops out, oozes out from that. That's also wastage. It happens in both cases, but concrete is same. Even if drops out, then you have to clean that area. Or either chances of opening are less because this is a small column and height is less and pressure is not that much in this case. So you can say fluid pressure is not that much because it is 2 meters under casting, and in layers you are casting 40-40, so it will by rotating it, it will take half an hour, 1 hour at least after casting first course to next course. That's point here. Two, or if you are casting let's say 1.5 meters, then you have to take 4 layers or 3 layers depending on concrete, depending on your sequence, and that's point which is important. Then after that I should say this item of stub is also very important because this is a starting actual column, and before pouring this and before fixing your preparatory works, you have to be very careful about construction joint between foundation and the stub column. And now you have to cover at top, means top of column, even by polythene, by some arrangement with the water. Just put water when curing starts, and don't worry about sides if it's not too hot. And side itself will support in curing. It may be for 2 or 4 days if you don't immediately need that shutter. So you keep that in 2 or 3 days, and then start opening it and use curing compound if it is you have. Otherwise, you have to do hard work on curing. You have to do spraying water on Haitian bag and then cover with that one. That's point where we have to be very careful. Try to have use curing compound because it's expensive, of course, but once you use it, you retain water on that surface. That saves your hard work. That saves your your water quantity. It saves your labor, and it works similarly if, and you use water retaining. Water, if you retain there by using water-based curing compound, it works well up to 70-80%. And even you use water, you want more achieve more success in that. Only sometimes moisture and relative humidity also helps curing. That point must be kept in view. So we move on to next item now. So this item is now it goes to where it was. Okay, now it is an item. This is checklist for grade slab, floating slab at plinth level concrete pour. Yeah, this is grade slab we call it, or ground slab we call it, or whatever. It's not structural slab anyway. This is not connected to beams. This is floating slab. Means there are joints around this slab, joints between beam and this. Gap is there, which is filled with flexible material or some other material, and that helps that joint. Item is that previous preparatory works were done. Now this concrete pour ensure that preparatory works have been approved and ITP signed off. Plan for one go, means without approval you cannot concrete. That's purpose I am saying that ITP has been signed. ITP means inspection testing plan signed, and approval is there. Plan, this also what I am telling is not on the side guys, this is also for quality people to understand, because they do not understand procedures though they are quality engineers. Plan for one go pouring operation, means we are saying in one go we will pour this, not in many goes, because this is slab 15 centimeter or 150 mm thick or 200 thick, depends on design. So we have to ensure that RMC delivery order is in place, that we have to place order, and then ensure that RMC manager is instructed about grade slab pour being fast, and show what type of concrete pump is required to cover whole pour area. And because there are many types of concrete pumps with boom length, make sure that single pump is adequate, or there may be needed more than one pump. Depends on your area. Some areas too big, one pump cannot cover, or then have batching. Plant manager inspect site himself for assessment. Decide frequently of supplies and pouring hours. That's hours. In generally it is done when you plan for the pour, what hours you want to pour, and decide workforce requirements, strength for pouring period. You have to decide for your own arrangement. It's not for batching plant. How many workers do you need there? You have to decide, because this is fast pour. You can't wait. Masons can't wait. Maybe you have to place 2 masons, 3 masons, 4 masons, depending upon coverage of area. Make sure all other concrete pour requirements are available, and that access to concrete pump and trucks is clear. Then quality engineer is required to care about testing of concrete. Preferably pour hours should match concrete temperature extremes. In case pour duration is long hours, rest pause to workers may be required, which necessitates standby teams. And safety arrangements are to be looked into as well. And safety engineer should care about check in case trucks have to arrive at frequent interval of, let us say, 10 to 15 minutes. While one truck carries say 8 to 10 cubic meter concrete, because this also requires some traffic controls, which is very important one, because you may not block road or something. Workforce shall be required accordingly, and surface finishes shall also be required depending on class of surface finish, whether it is wooden finish or it is, you know, say power float, or depends on what type of finish is on that. So generally you will say wooden float is enough. If you have to apply for power float, that's different issue. Check whether or not power float is demanded for thin tiling works. In case it is required, post pour long hours shall be required for operating power float, and have pour started and implement all checks. Curing should be commenced with immediately after area is ready for that to receive that curing. Curing compound should be sprayed immediately after or even during pouring is in progress. In case of unpleasant temperature, cover surface with polythene, cover finished surface with polythene sheet over curing compound temporarily. After many hours, remove polythene sheet and cover with Hessian cloth watered and recovered with polythene sheet. So process of curing to continue for a specified number of days. Make sure that set concrete surface is ready to be applied with power float or demanded manual finish, whatever be case. So this is your ground slab. Ground slab or grid slab means it's a different type of a structure. You cannot say that structural one. It's you can say actually a floor. This is a kind of floor which will receive some finishes, but this remains independent of structural integrity. That's only difference, because if you connect to structure, though it's nothing wrong with that, means then you have to calculate its connection with the stresses, which is generally not done. It's just independent one. And if you, because if it sinks, you know, let us say there's some sinking due to some reason, then structure will not sink, only floor will sink, and generally this happens. So we leave it as grade slab. Means this only pouring question here is, it's, you know, there are so many openings in that, possibly WC opening or bathtub opening or some other opening, some other, you can say, condensate drains can be there. Various services could be there below floor, maybe water services or sewage services depending on location of floors. Or there is no services at all, even then electrical services will be there. Electrical first fix will be there, and that inserts you have to maintain in this concrete. And this is because it is open one, it's not confined concrete. Pouring is not a big problem once you are ready. There's no major steel in that, just, you know, BRC is there. In fact, this is WWF, welded fabric is there. So pouring is not a big problem. Only it is rapid fast pouring, and it should be done in that way. So this is that point. Now I'll go to other point, which is checklist for RCC columns concrete pour. Checklist for RCC columns concrete pour, and this is item number 10 for preparatory works, and this item, this is concrete pour. How much time I have taken? Let me see. I have done 2 hours 30 minutes. So that no problem. So this is some more water left. Some quantity of water is right up over my throat section. Now, ensure that adequate number of columns are ready for pouring. That's the important point. because it is same like step columns where quantity is little more, that's it. Ensure that adequate number of columns are ready for pouring. Make sure that all columns preparatory works are clear of all dust and dirt and well watered. All nails, loose binding wires, etc. should be taken out. Quantity of RMC should be enough for placing an order, though tentative booking might have been done in past, but confirmation is required now. Required boom length pump must be ordered, and ensure that preparatory works have been approved and ITB signed off. Make sure access working platform is ready, which is a very important item. To safety satisfaction duly tagged in at all risky droppable heights areas. Make sure that all supports are in place or all clamps and bolts are intact. Make sure attendance of steel fixer and carpenters for responding during emergency of sides opening or some other requirement. And competent pouring gang is deployed for required duration. Vibrators are available and in working conditions. Make sure that standby vibrator 2 works in according to requirement, and all curing arrangements are in fact intact for immediate application. Make sure that all concrete pump and first transit truck mixer arrives as advised to plant okay. Make sure that additional reducing size out of boom, reducing size out of boom is attest if so required. What does it mean here? Let us say whatever size of pump pipe is there if there is a smaller section, let us say in column the smaller section where that pipe doesn't suit in, but there is a reducing union also. Reducer also is used on the pipe to reduce size of pore or diameter of pore. Reduce diameter for make sure that additional reducing size outlet of boom is attached if so required, keeping in view depth of pore and size of column section. Then arrange quality assurance engineer for testing purpose. Quality engineer is there. Concrete has to be cleared after initial site tests are completed. Then ensure weather and concrete temperature, before allowing truck to station pump. Make sure vibrator reaches to lowest layer of concrete. That's very important. Otherwise, you shall leave that portion void or undone. Make sure that layers are not poured at one time more than 400 to 400 or 500 mm as usual in vertical pours, and make sure that vibrator needle does not touch formwork. Then also make sure vibrator needle does not touch rebars, and make sure that all columns are poured one after another only in layer. It's advised that in no case one time height should exceed 1 meter for preventing form sides bulging. It's advised that in no case one time height should exceed 1 meter for preventing form side bulging. Possibility is that concrete shall fall out of column forms and must be removed immediately from ground. Hammers can be used to tap forms. From exterior surfaces to ensure that all areas of forms have received concrete to avoid any void. And then concrete gang should be capped on rotating from one location of column to other location. Concrete gang should be capped on rotating from one location of column to other location. After completion of all pours, side should be clear of all debris, and wet hessian should be capped on top of columns. from sides in case of high temperature should be kept wet by spraying water on exterior surfaces. Foams should not be removed from columns before 24 to 36 hours depending on weather temperature. If there is no requirement of immediate reuse, there is no requirement of immediate reuse, foam stacking may be delayed. This requires keeping exterior surfaces wet with water spraying. Immediately after striking foams, urgent inspection has to be done for some defects, if any, and for curing and for resorting to non-compliance reports as well as recommendation of remedial actions. Curing has to be effectively continued first by applying curing compound of wet RCC surface using either water-based compound or wax-based compound as approved on project. Then complete duration of curing has to be complied with either by any slackening or compromise. Water curing can also be done on columns which shall be more effective and in fact cent percent effective if carried out intensively. So intensively tough quantity of water consumed shall be considerable. Curing compound based curing is effective only between 50 to 70% depending on type of curing compound. So this is about columns which have its own restrictions, its own requirements. Column, which I said in this item, means there is no meaning to do one or two column. There may be hundreds of columns on any floor, and you have to decide how many columns you are going to do in one time of concrete. And let us say, for example, column is say 0.4 by 0.4, let us assume, means 0.16, and if it is 4 meter high, let us say 0.146 or 16 into 4 meter, this is 6.164, this is you can say 64.64 0.64 cubic meter. It's not very big quantity, but if you say stack 10 columns together, then you know the quantity how much. So even after this quantity, there's no justification of going through column connection with your columns connection with the concrete, because let us say 0.164 into 0.16, so 0.64, and there will be 10 columns or 20 columns. So quantity is not that much. The only frequent supply of concrete, and it's very slow activity. You may say you start first layer or second layer or third layer each column, which doesn't go about 0.8, but we know what's happening there. If you have to vibrate those areas, vibrate those volume of column, that is very important exercise, and your vibrator must reach down to that 4 meter depth. So you need that kind of vibrator which can lead to depth at kicker level, and from there it can come up as concrete moves fast, goes on. You should wait for, say you cast half column, and then you wait for other half column, and after taking complete circle on columns, then you come to the last column, first column, and this should be before its whole joint starts, and you can see another layer occurs on that point. You must keep, and again level field is there for purpose of pouring, and all these tests very well. I told you can take this test. Then it is column casting is very patiently done. Just remember, if there is honeycombing in column, If there is void on column at kicker level below, it's very difficult, very risky. And this is ultimate load bearing column, means all loads are coming on this from slab, from beams, and this is means ultimate powerful structure that can add to stability of structure, because first of all it doesn't, it's vertical member, upright member, means it is very powerful member, you can say. If first of all bending is not big issue here, because you won't see bending by eyes, it's only its own issue. And when you think that if you are successful in pouring column, no honeycombing, no wires, nothing, that's called efficiency, because it's height 4 meters, and you think that you come down to 4 meter in first layer. First of all, you are taking your pump chute down, and 1.5 meter above that, means you are taking a 4 meter columns 2.5 to 3 meters down your pump boom. It should go smoothly, that is first requirement. And if you think that it doesn't reach smoothly, you can say that there's another requirement. Now if you are able to reach your down level of 4 meter and you pour concrete and vibrate that one, your vibrator will tell it's done full or not. And then also above, problem also is there, because you are using a pump is with full pressure. If you are using a pump which is with full pressure, there are chances that your column may lose its grip, your sides may lose its grips. For that purpose you are using bolts also. Chances are remote, chances are rare if you have used bolts or you have used clamps, and you have used all supports which are required at all 3 levels, all sides or on 2 sides or 3 sides, as depending on what location of your column is. And if you are able to support that without bulging, without opening of sides, or without any other problem, and having good control on kickers or starters of that, and your columns will be very excellently done when you open shutters. And you should know that if shutters fail and there's no immediate risk, but the risk is that one. This point results in column pouring, and moreover you are going to pour column, you need some access to that height. That's very important. First of all, that's a 4 meter height. You cannot jump and take vibrator there. You need platforms on that. There's a 10 column in one row. You need platform on that layer. You can walk, and that should be safety approved platform. Means there should be handrails on side, and there should be ladder case to go up. And it is temporary. You have to walk steadily on that platform with your vibrator here and there, here and there. It should be strong enough for the people to work. Though it's required very temporarily, but it's very expensive, and you have to do that. So that stair ladder, or you can say, is very important. If you can then move on that platform without any worry, that's called safety platform. Means nobody should go who doesn't walk on side. If somebody goes, it goes through your secretary and your you can say. Now you are standing on a platform which is 4 meters high, and you are having 10 people there, 2 vibrators there, 1 vibrator here, 1 vibrator there, and you are starting from one corner. You are doing still a cast for 2 minutes and come to other one. Somebody uses the vibrator there from top and reaches to 4 meters below. This happens. First layer is very important in this case. When you pour 10 columns, means you are going to pour, let us say 100 layers. Let us say 10 columns you are pouring. 40 centimeter pouring in one layer, 40, and the 4 meter height. Let's assume this, and this means 10 layers are there, and in total 100 layers are there. So how you have to think how much you can do. For example, your pump boom is down in first layer. It will take say half a minute only or 20 seconds only to finish that one. Then you have to take up a layer. Then now you are first to take out that layer, that pump boom from outside, and apply vibrator there on that first layer. That's most important point. You apply your first layer is 40 centimeter beginning, and you can say this one you have done very well. You're satisfied with that. That's gone all corners. And how to know that is also important. Some carpenter can go outside with the bottom portion, use a hammer and see by ticking this. You will know whether this is if you on that shutting you will knock like this. You will find a sound hollowness, hollow sound, or solid sound. If you find solid sound, means concrete has reached there. If you have some hollow, concrete hasn't reached there. That's called a kind of integrity test. You may say, though it's not integrity test, this is just a side test. Means concrete must reach all four sides, touch those sides, and then vibrate. So once one layer is over, then don't run away from there. Again drop your pipe and take second layer and take out pipe and then vibrate there, and then third layer and then fourth layer. And fourth layer or even your third layer you can do fourth, then you take it to some other column. Third layer is 120, you may say also 1.4, fourth layer so 160, and then you go to other one column, other column, and then until all these 10 are done, and you see how much time it took. When you come back to first column, if it is applicable time according to your specification, and within 1 hour you will accept it, that 1 hour will be how much? If you have taken 5-6 meters, so these 3 layers you cast, let us say immediately, and vibrate it. After it you continue to other column and then to other column and then come back, another 3 layer and then come back, like that. You are all these 3 layers you cast are hard joints, and then further you will cast in other columns all hard joints. So this is technique behind that. Immediately cover from top. Immediately cover from top, don't wait after pouring. So whole area, whole columns you pour like that, which shall be used by shopkeepers like some other, and that's a requirement. Continuation rapidly is not good. In layers it's good. First layer, second layer are very important layer, remember, because you are covering 80 centimeter, and also third layer. First and second are very important. If you are careless on this layers, you will certainly result in honeycombing and void of column at that point, which is near construction joint. This point we must keep in our mind, because such are only methods that can give us experience. And you don't take much also. Whole weight of concrete, whole pressure of concrete will come when it's full. Just remember. Let us say 4 meter, it means 1/3 of 4 is 4/3. 1.33. 1.33 means from down to 1.33 meters, which is almost 3 layers. 3 layers load is there. It doesn't matter when you go to 4 to 5, 6 layers, you will find load also shared by this, force is also shared by this, which must be registered by your system, by your formula. And this is what I say. This is a very important point, and you apply correctly, you do correctly. Even photograph or face of that one, you will find very very, we call it progressive formula, progressive stage. Once you are working with progress, you are working with something that is required. It's professional work. So you do that 3 and then 3 and then 3, you will find more or less you have crossed our population here for this purpose. That's only point here which I made for column casting. And column casting is not that easy alone. You have to keep in point also if dowels do come at that level. Though I have not taken this into the text, but dowels are very important sometimes to be allowed. So what can I say? So that there are three points we have kept in. One is that which type of shutters we have used. We know what type of shutters we have used, what spacing there. You keep 40 or 50 centimeter spacing between framing and support in this vertical frame and horizontal framing of that one. Timber from file or packing, and you have to use 18 mm, thickness of ply, and all nails you need, whatever dimensions the exact one, and you have to check location of all these columns before pouring. And platform is very important, temporary platform, safety based platforms, and people work on that. And then in top there may be two platforms, or one go directly above one. If your concrete is not good in these columns, this is a very dangerous situation, because concrete test will be conducted. You can't avoid that. If that test is not reliable, what you do? If that test is not reliable, what you have to do? That's the point here, Well, let us see how long it can hold. This is Mr. Sorrow Kumar, welcome. People are coming late. So this was about column, and one more thing I have to tell in this. I forgot to tell about these dowels. What happens sometimes, beams transfer their moment bars or your main steel in both compression zone and in tension zone. There are bars provided for hogging moment or for sagging moment or for final whatever moment is there. Then that moment is transferred to columns in both upward and downward directions. So those points, those bars, if are available according to strict design, must be added to these columns. That is a small criteria here. You have to be very clear, means those if those bars are there, if those bars means coming from beam, go to column, let's say 1 meter down. In that case, you either fix those bars, leave it to top of column and cast in that, or do not cast column up to 4 meters, cast up to only 3 meters if that size is there. You have to depend upon how much you take. So you are taking 12, then that size, and then below. So that's point here, that we have to cast dowels also, 20 mm, 60 mm, whatever dowels we have for other one, or columns, you have to do that. That's a part of profession, part of engineering, and that must be done in proper level. It must be done, not otherwise. So that was checklist of columns I gave you. I'll move further now. Let me see if something is left in that checklist, because this checklist is very important. Let me see any point is left in that. One by one, we'll see again. So it says adequate number of columns, that's fine. In columns, pretty works, that's fine, it's over. RMC order, then you can say boom length, that's okay. Preparatory works have been done, that's okay. Then access working platform, as I said, very important. Safety satisfaction, duly tagged in, all this doing. So that's like safety platform. I've taken this in your safety talks. You can refer to that. And then it comes to preparatory works are over. Then boom length you have to check off pump and all these. Then supports in place and all supports. Attendance of steel fixer carpenters are here for response, and opening or some other treatment. So which says, means as I explained earlier, these columns are to be poured gradually in layers not exceeding 40 mm, 400 mm, and applied directly. So I would say now all that is done. Now it's a concrete pour for RCC walls, That's also very interesting. RCC was complete 4. And it says, sometimes, it's very interesting to talk technicalities of project, but people are not interested. That's another problem. I was not lucky to get all this information in my time, so I try to create all this information for myself and for others. Means I tried what I could not have documents from my work, but I could remember what I did. So I documented all this myself for my reference, and then now, because the public should know about this if they are interested in engineering. Just taking drawing and coming back and not discussing anything, it's not engineering. So let's go to RCC walls complete code, which is also very, you can say, RCC wall. I think, well, I may not be able to show you now some sketch. Maybe I have not. Let me see if I can show you something. It's better if I have. Let us see in this. I'm not showing you the detail. Let me see a book if I can get one here. For example, if I can, here I've seen something. I should find something. Yeah, I got something here. Something at least, it's not everything. Something is preferable. Let's just for a glimpse I'm showing. I'm not exactly showing it. Just a glimpse. This is some kind of detailing. This is also a combination of that. Okay, I can't remember. I'm trying to find out that. Now, what it is? Now, preparatory works have already done item number 1. This item is concluded. Make sure that wall works have been approved. That's okay. Whether walls are to be poured, whether by pump or by crane, that we have to decide. Walls are not many in any building, so it says since walls are not many in buildings, pour quantity may be limited. Check all working platforms are safe. What platforms you have to work where there are wall shutters were done. So check all working platforms are safe, which may be installed from either side of walls. Make sure that preparatory forms are cleaned Make sure the preparatory forms are cleaned properly, leaving to unrequired dirt. Make sure that preparatory forms are cleaned properly, leaving no unrequired dirt within. Ensure that plenty of free access is available to reach either concrete bucket, chute or pump boom to level of first drop of concrete. Make sure that preparatory forms are cleaned properly, leaving no unrequired dirt within. Ensure that plenty of free access is available to reach either concrete bucket, chute or pump boom to, level of first drop of concrete. And certain cases of thin walls, elements reducer shall be attached. Elements reducer shall be attached to end of initial original pump boom. And check all concrete pouring inventories are explained on other previous lists. And make sure watering into wall, that is, make sure watering into wall works are well as supports being intact. Ensure availability of carpenters and steel fixers. Check that plumbs and wall line are in position to monitor any setting out alignment. Receive concrete as usual. Check through quality engineer for all tests. After approval, allow concrete to wall location. Pour wall first layer in all walls and apply vibrator correctly so that concrete reaches all corner and edges of first layer. And pour other layers as usual in sequence gradually. And it would take hours for pouring a single wall. Reach concrete to top of concrete material, concrete marked line, and give required elevation. Then pour whole first layer in all walls and apply vibrator rightly so that concrete reaches all corners and edge of first layer. Pour other layers as then pour other layers as usual in sequence gradually. It would take hours for pouring a single wall. Reach concrete to top of concrete marked line and give required roughness or demanded. Then it will take hours for pouring a single wall. Reach concrete to top of concrete marked line and give required roughness or demanded. Finish. Apply first instant curing on top by covering with polythene sheet or then rough concrete to top of concrete marked line and give required roughness or demanded. Finish. After apply first instant curing on top of covering with polythene members on such walls. Then apply water on forms exterior and this for check if forms are not removed prior to at least 48 hours are passed, and apply water on forms all forms exterior and on top to for curing purposes after few hours, and clear all doors. Okay. Now clear all debris from around walls area of access. So this is simple statement of wall actually. Now what wall is about? Well, we say it's wall, but it is very important structural material element. Means walls are generally for what? First we have to think. It's around lifts. You can say lift wall I have taken separately. So forget that. Otherwise, where are walls? Generally, walls are done 100 meter or 150 meter thick, or more than that also. There are shear walls, there are curtain walls in still, you can say not in glass but in some fencing areas. Fences are there, wall is there, and it's all structural walls. Structural walls, you can say seismic design walls, or you can say these are like extended structure. What they do, they put this is four walls. Now let's move further. What type of walls I'm talking about? It's very important. Before I leave this talk, Mr. Sam, you're welcome, Mr. Sam. Okay, somebody is interested. Let me enter first this. Otherwise, okay. Lift valves are different. I'm not talking about shear valves. Also, a part of that can be considered here, and also other valves. So I'm taking valves. Vault is about 4 meter high, 3 meter high, and some is 100 thick, some is 150 thick, some is 20 200 thick. Some is depends on that. But it's actually a big column. You can say big column in a sense, not for design purpose, for pouring purpose. We have to do pouring like that, but in this case, because this is wall, there are internal bolts in that, and there already platform is built because you have prepared works on that. We have put shutting and steel and all that. So very strong platform must be there, and already it is there. That's from safety viewpoint, and pouring, that's fine. And you need preparatives like vibrators. The walls are many, and these are two. You are using the tower crane, or maybe generally mobile pump is also okay for this. I will prefer mobile pump area because other takes a lot of time. If you use tower crane, it takes a lot of time. So pump is better if you can have on that height area you're going to build valve. That's more important. Now, if it is 150 wall thickness, then there will be finally one mesh of 150 If you find two or more, than it's around 100, 180, and those covers the walls. Now, depth is same. You can see all times depth is same. Now, first of all, cleaning is very important, and before that, you have to see threading. location of wall, because it is slender structure. There are chances that moves out, because it's not bound by four sides like column is bound by all sides, clamped in, bolted or whatever, and particularly sloped. So yeah, and there is are some stops in between columns. The positions remain same, but wall is different. It's a thin structure, and this can move from this way to that way if little disturbance comes in. So we have to, of course, platforms we're all boards within PVC pipes there, no problem, it's okay, fine now. Polythene pipes and boards are there. But we have to be careful. If it moves, it is a problem, and generally walls are fair face, these are not there. So we have to check all supports, we have to check all boards are all okay or not, and we have to put some thread direction, or you can say also, in addition to threads, some plumps must be there in vertical, so they're already there where you checked it, inspected it, got activities approved. So plumps must be, let it remain, don't take them out until so. And that's a one pump block, one tire is there. So clearing is first point. The stringing position also there on top and bottom, just to ensure that it is this position. In case there's some movement, you can see what difference is the right. Though it doesn't happen if everything is right. So wall is also a complicated element, which you have to first clean it. Then you have to apply preliminary concrete, which say number 9, 3 layers or 4 layers or 3 layers. Let's say some 3 layers are there, 1.25 meter, and then sand it. So cleaning almost same, no difference in that. You use compressor here, clean, and use water also. If this is hot and you want to avoid flash setting. A point comes in, you are ready with this, you have a platform there, you have workers there, you have vibrators there, you have your in station, your pump or mobile pump, or your you can say tower can, everything is there. I use a mobile pump you have. Then you add concrete as well. But wall is not matching much concrete, smaller concrete there depends you're taking from your source. Let us say 5 meter by 4 meter walls, that's a 20 square meter, and it's a 30 by 30 means one third. So it's that means first layer is very important. Before you have to apply first water in that, so that steel and certain get cleared at low temperature, and then pour one layer of 40 centimeter. One layer 40 centimeter, you have done that, one wall, and then second wall, and fourth wall, very sharp, and provide your vibrator. You can do second, I think it don't go to the 80 centimeter all it down, and you repeat on all that, come back and do 80 centimeter around, so 1.6 meter, vibrator goes in, no problem. If it goes in, and if it's accepts your productive works for its staging, for its absorption, I think there is time. Now I'm getting information so far. So clearing first of all, and if there's any hole, after clearing remove the hole. First layer you lay. Yes, the point is, because thin wall reducer is important on pump home, which is 150 mm. We have going to suitor. The stupor should go there. Right? And compressor here, cleaning block, water, flash raise white. So 1 layer, 2 layer, and 3 layer, and stop it. All these 3 layers vibrated. You see your scope is moving ahead. Now first layer is done, second layer, third layer is done. Hold on for some time, maybe half an hour. Once you have laid 3 layers, you check your thread. If it's in position, that's fine. You thread to shutter, you have to check, because from thread to shutter, you have to. your thread is in position, if your shutter is in position, there is no movement, you should be happy with that. That is submerging, and apply another 2 or 3 layers. So after that, stop again, because hydraulic pressure you have to be careful about. It's 3 meters wall, means 4 meter walls. There enough hydraulic pressure. So all these layers you have checked, and you do same procedure around, and you reach top and it's fell, and that's a stage where you need actually such arrangement of stocks. So as it says 9 inches, then 9 inches, 10 inches, 9 inches, 10 inches. Once you reach top level of your wall, where you see there is, your nail fix or some side fix, and you are going with that one, that time your pressure will be full, and that pressure should stay there. It is, you see, tailored. Wall, in that case, you can form full height, and then pressure is full. That time you have to check your movement is there or no. If there's no movement, you have to just keep resultant support. 3 supports already there, one on top, one at that point of result, and the bottom. So these 3 supports are there for help. So that's all about. And yes, also that you can say your wall is thin, you have to apply, to add reducer below your boom, below your disposal end of boom, so that wider size, or can say pump maybe reduced to 75 internal diameter, so you can reach all corners of your congested steel. It's still very congested, so that point you must take care of. I'll move to now I'll move to okay, then this is now lift wall concrete pour, lift wall concrete pour. Lift wall, actually. Lift or elevators, we generally pour, and these are RCC structures, not here in our country, but this should be RCC structure, because this can give double benefit to you. To some extent, this can act as core of building as well as elevator valve, and also you can to some extent use them as shear wall as well if you wish. Not necessary, but can be. So this is of course wall, and not 100 mm or 150 mm. This is reasonably thick in like column designs, in like column and heavily reinforced, and this is very heavy structure, actually heavy in the sense of its design. It's not ordinary. So let us say how we pour it. I explained to you about this preparatory works in talks in past. That was item number 12. Now it's item number 12 in connection with 33. That's concrete pour of lift well walls, and preparatory works are all over explained. Now I'm going for further this pouring on this wall by this wall now. Let me say, if I can take some water from directly from this, I don't want to feel hungry or thirsty. Let's say, make sure that wall works have been approved, okay? Approved for pouring. Check all working platforms on both sides of lift well are safe, which may be installed from either side of wall. Means there are platforms outside lift as well as inside well. Check all working platforms on both sides of lift well are safe, which may be installed from either side of wall. So we have a benefit here that we can use both internal and external areas of this shuttering. Now make sure access working platforms ready. Of course we are working there, we're fixing forms, so we can add more platforms and remove that portion probably. We have to modify that for better arrangement, because now many people would come on that. Previously only carpenters and helpers were there, now there are many more in a sense, mason, concrete crew, you can say, concrete crew and concrete vibrators and all additional tools etc, and people shall use that one. So it should be revised with safety and everything, and they have to stand inside as well, so they should be having good lifeline wherever. And make sure access working platform is ready for safety engineer, and check all working platforms on both sides of the well are safe, which may be installed from either inside or outside, and make sure access working platform is ready to safety engineers satisfaction, duly tagged at all risky or droppable height areas, and ensure that preparatory works have been approved at ITP signed off, and make sure and watering into wall works as well as supports being intact. Availability of carpenters or steel fixers to control any displacement if preparatory works. Check that plumbs and wall line are in position to monitor any setting out alignment, and just check the pipe, plumb and wall line are in position. That's very important, because already lines are there and plums are there, which must be revisited and checked, and maybe there's some displacement to avoid that, and make sure that all supports are in place and all clamps and bolts are intact. Make sure attendance of steel friction carpenters for responding during emergency of sides opening or some other requirement. And make sure competent pouring gang is deployed for required duration, and make sure that vibrators are available and in working condition, and make sure that standby vibrator 2 works in accordance to requirement, and all curing arrangements are intact for immediate application, and that concrete pump and first transit truck mixer arrives as advised to plant. Make sure that additional reducing size outlet of boom is attached if so required, keeping in view depth of bore and size of column section. Arrange quality assurance engineer for testing purpose. Concrete has to be cleared after initial site tests are complete. So we are starting that, you can say. Quality engineers, they are saying that concrete has to be cleared after initial site tests are completed, and you have to be sure of weather and concrete temperatures before allowing truck to station prop pump. Make sure vibrator reaches lower layer of concrete, and that layers are not pointed at one time more than 400 to 500 to 500 mm deep. Make sure that vibrator needle does not touch formwork, and make sure vibrator needle does not touch debris bars, and you can say explain to concrete supervisor that pouring has to be started in such a way that corners are poured first to have concrete move in all directions uniformly to certain extent. Make sure that concrete layers are formed around lift. Concrete layers are Then you can say make sure vibrator needle does not touch rebars. Make sure vibrator needle does not touch formwork. Make sure layers are not poured at one time more than 400 to 500. And explain to concrete supervisor that pouring has to start in such a way that corners are poured first to have concrete move all around uniformly to a certain extent, and make sure that concrete layers are formed around lift valve. Concrete layers are formed around lift valve forms, and due care taken to door position one for door position one. Pump booms has to keep on move. Pump boom has to keep on moving around preparatory works to allow uniform pour. All layers have to be vibrated thoroughly, gradually, and concrete has to be capped on pouring till 1 meter high. That is a drop down. Alright, then depth is poured around. Then make sure that at least half an hour gap is allowed to pour, so that pour concrete sets to a certain extent but does not form cold joint. Pour other layers till 2 meters. Pour other layers till 2 meter high. Depth is completed, and allow say another half an hour for resting. Then continue whole height. Continue whole height following specified sequences, and start cutting initially as explained previously. Make sure that top of concrete wall is roughened for making construction joint. All walls outside forms have to be kept wet, and top covered with polythene or wettation. Check external forms are check external forms as well as internal forms by strong hammers impact to find in case some voids do exist during application of vibrator. Make sure that repetition of forms would not be required soon, which means that there would be no earliest requirement to strike forms in a specified duration. Then, in case of such non-early requirement of striking, do not allow removal of forms after 48 hours, but keep curing intact from top as well as from outside. Allow removal of forms when it is to be repeated for higher levels. Then, during monitoring of forms, make sure that lines do not go out of tolerance limits, and in trying to reinstate by lightening the supports. Right, then you can say make sure repetition of form would not be required soon, which means that there would be no earliest requirement to strike forms in a specified duration, and based of such non-early requirement of striking, do not allow removal of forms after 48 hours, but keep curing intact from top as well as from outside. Also, allow removal of forms when it is to be repeated for higher level. During monitoring of forms, make sure that lines do not go out of tolerance limits, and if so, try to reinstate by tightening supports. After striking forms, make sure that defects are identified for raising non-compliance reports and recommendation of remedial actions to be NRC. So now what we're talking is extremely extraordinary item. That is, this is not an ordinary item. In fact, generally in our country, on lifts they don't use RCC. Those should be. I don't know reason for that. Architects know, structural engineers know. Let us assume we are using that. We are using RCC, including RCC on lift well. First, form work is very complicated. In this case, you must have seen when I talked of this item of form work. Form work and your reinforcement both are complicated in this case, because first one is that form work is of course all around internally as well as externally in full height of lift. And this internal platform which is held, we either we have come from below, but if you come below it's expensive. If you are able to form a slab level, little slab level one platform, it will be much better. It's forming, how to do that means just make a platform there, or some girders, timber some of the girders, and let's say you have so 2 months. Before that, you have so 2 months, so somebody so take so then. Now we have external as well as internal. This is common, and then there's a door. There are there are complications here. One form work internally, one form work externally, and there are connections by bolts and polyethylene pipe. This is one go. Then there's internal door, means formwork and door inside. There's an internal built-in formwork, which is not seen from outside, but it is internal. So first you have to do formwork of door, it's like holding formwork and then the actual formwork. This is what we have in addition to steel reinforcement. We have reinforcement up to beam bottom level. We are not taking beam because beams shall be taken this slab. So we have finished all that portion, and this internal entry door is completely blocked, completely, there's a support stingers and all that. It's now locked. How to do formwork in this case? Alright, now we move further. I was just thinking of how to explain to you, because this is different one. Just be free in mind. Formwork is very strong. There are bolts, there are supports, there's platform above that. Completely you have to modify platform, because many people are coming on that. Maybe 2 or 3 vibrators are there, people are on this side, people are on that side, all side people are there, internally and externally both. Heavy manpower. And then pump. Which direction I don't know, is a banksman or pump, some other reason. You have to direct that pump to sitting on ground. What you are on means you have to transfer signals to them. So that has to be managed on site by bank people, by intermediate people. And what stop complete, do complete, stop complete, do complete, like that. But pump boom is managed by your people. And there will be a reducer with that pump. This means if say 4 inches pump, there can be some, so 3 inches it takes down. Up to 3 inches, so there can be small channel or something that is still very, to say very costly. Then you can use this timber only for your home, but it's not for home; it's for industries. But study is there that this is industry, and this is building or whatever, where people are coming and going in. So it is a structure which is very strong, and then you can say we have to ensure that door portion should not allow bulging from its sides. There should be no bulging on anywhere. If there is no bulging, means there is some bulging, of course. You should see that way. So bulging we have to avoid. Opening we have to avoid of rolls. And concrete will in heights, and then temperature controls, and then you can say from where you got this. So we have to be ready with this. It is complicated for. Why it is complicated? I understand. This is a square, complete square with one void, and that is door. So this is unbalanced one. Unbalanced in the sense we cannot pour around in one go. We have to pour around but cut up door. Let us say we start with one corner, or let us say we start with other corner, but either you have to pump one pump, you have to use one. So you start pouring in. You first to clean that. Of course you have to clean, no way. Then you have to see flash setting question. So you have to pour water if there is a question flash setting. And then you start pouring. Let us say you pour all that. Let us 4 meter is center is 4 into 16 and minus 1. That's door. So it is 15 meters. 15 meters you have here. 4 into 4, 416. And 1 meter say this door of the door. And so 15 meters into, let's say 30 centimeter width into 30 centimeter width, and then height is, let's say 0.3. Or is it 0.4? How much it is? See the quantity of one coming in. 16 into 115, 15 into 0.3, then 16 into 1 is 115, 15 into 0.3, 15 to 0.4, 6, 15 into 0.4 is 6, 6 cubic meters, 15 meters, let us say, 15 meters into 0.4, 0.6 cubic meter in one layer. 6 cubic meter is not also small, you have to think that way. It's a big one for one layer. You understand? That is 16 into minus 1, 15 into 0.4, 15 to find 6 meters, 6 meters, 6 meters, 6 meters, 6 meters, layers to there. Up to 2 meters door, which is 40 into 5 layers. Then above layers will be full 16 meters, more than 6 or 2. What to do then? You start from one corner. Either doors from start from door or start from the corner. Better start with door, or you just start the corner and let it go to this way. Door side and some to that side. Don't hold there, because it will move automatically. It will move automatically. It will not stop. Once you start pouring with the speed also, when you go down to 4 meters depth, when supplies come from, it will not stop pouring, and you completely pour one layer. You move this pump from here to there easily, and slowly end up with this door, and then there and there and there, and come back to your terminal. So this is 6 meter. Okay. Which means 6 kilometer you pour around one, you can say around 3/4 of your or transmitter. Now you have seen that this gone to whole layer. You start vibrating this. Vibrating it. When you start vibrating, automatically it will come to level. So you have used the movement of pipe. You are not just station pipe pump at one point. You have medical like this and this and this, and then to some extent it's not very good, but you have when you vibrate this from one point to other point, where maybe to how many times you have to vibrate this. You have to vibrate a lot of times, but not some other material. Like now this, and then after 1 hour I like this one. So 6 layers, 6 layers, 6 layers, 6 layers, and 6 layers. Be very careful. This 6 cubic meter, and then when you reach another layer and another layer, about 1 meter something, hold there. Because 1 meter is already there. After vibrator, just hold there for 15-20 minutes or half an hour before your joint becomes cold. Depends on what type of cord it is. GGBS can hold that. Microscope can hold that. So hold it for that. And then you start another one. Interlock in all layers. All layers must talk together. New layer, old layer, new layer, all must, and then you do another 1 meter. So door is finished. After that you have chance 16 into 6, 6.4. So 16 into 0.3, 16 into 0.3, 48, 4.8 into more than 1. So you have finished at 1 meter. After that you start again. Start again. Maybe you put some slurry, no problem. And you start and do all one layer, then another layer, and then another layer continuously, 3 layers. And each layer start your plumbing or your curing, thermal, what do you call it, laying, sorry, not thermal, laying of concrete in each layer up to though this 2 meters now over. You have to be careful. You check your lines at the same time, where you put threads and all that. It's not going out. Just the plumb is not going out. All that you can be checking. I am sure this will be okay now, because your framework, your fixing, your shutting, your formwork was very strong, and you have to show that all covers of cover are intent. No cover should go away from steel. Because steel also remains intact. If steel doesn't remain intact, means this is not acceptable. And then you go to the last one, which is you can say remaining portion of lift is about 2 meters and 3 meters, 1 meter more, which is say in 2 or 3 layers, possibly all 16 in 3 layers, and which every layer provide this. So on every layer you have provided vibrator, even if a lot of customer mentions vibrator, no problem. And then you can say this is my total work done. So your total work done is there. Your total work is done, but be sure of movement. There's no movement, of course there will be no. If you feel there's no movement, it's very good. Reach top level. I'm vibrating everything. If your strong formwork, your correct fix, you will be happy that you have cast yourself. Do not finish on top, because it's going to receive beam of structure. Every slab beam you have to see at every level, because it's going to be your slab level. Your beam shall be here, beam for roof at that level. That's very important. And you can say wherever joint is coming, one joint is coming here. Alright, now you have to just, if you can make at same time some reference on this, though it will not work. You have to achieve it again. So this, what is said, is your pouring of lift. Pouring of lift you have done. You have to make it rough also, and you have to cover that portion after applying your compound, or not compound, but just core with your polythene. But certain corrections are which are not done. These connections you have to do. Corrections to semi-fold, correction to specialty. Your point is you can roughen that surface. You have to cover that surface as well, because it's big quantity. It's, you can say, 6 into 9 layers. 6 into 9 layers. Say 55 to 60 cubic meter concrete. It's big concrete. It must give good heat. 6 cubic meter means 9 cubic meter means say 55 bags. 55 bags is what? You can see yourself. How many kilogram of carbon dioxide will come to that? 55 bags. We say 50, let us say 2,500 kilogram carbon dioxide is released. 2500, 2.5 ton carbon dioxide. So you have to be careful about heat. From even ply, you have to arrange temperature. You have to, because immediately you are not going to this. But when you go to this, you have to be careful. Means you have to be very smart to ensure temperature around that and within that. Inside temperature and outside temperature. If it is not within limits, you must spray something. Whole spray for share this on some parts. I'll just show you that sketch if I can show you about lift before going, so that I remind you what I'm talking of. That very complicated sketch. I'll just narrate it to you, but it's very complicated one. Should be understood properly. I'm not in a hurry for that, but very important work. I did that work and I faced some problems. I was even asked by someone to give me details that you have taken these shutters and you are sure about these shutters. I justified my calculations there, and let's not, I think maybe it's not here. Let me see if it's there or not. It should be here somewhere. Many sketches probably that one. Yeah, I got this sketch here. Let me show you first of all what is about door. I'm talking of this door here. This is a this is door cover here within this left. You see, this is the front and top and side of that door shutter. Shutter internal one. This is shuttering within shuttering. This keeps this void closed. This is one here. You can see this also, it is not clear. You see, you can see. Shutter. And then you go on elevations. I'll show you what it is elevations later on. First I can show you all this. So, here is that. This is important point for understanding. This is left. This property also is talking. Is that one. You can see that one. This is timber formwork with bolts inside and all that, and then I'll show you some details of this further, because elevations here, elevations of this I'll show you here, and I'll show you other part here. Maybe you say what is showing, just to show that something should be done like that. It's not very clear, but yet it is. I'll show you details of that. It's also not very clear. Let's see, no problem, clear or not clear. Something should be seen or something is there, that's all. All internal and external elevations are there, all. This is, this is quite a big job here. Maybe you are not experienced that work. People do that and they go away. But I try to just do it for me, for my interest, you may say. And well, my purpose was just to accomplish this item in a better way, and it further says, let me tell you what it is now saying. Concrete pour lift well valve. Make sure the top of concrete valve is roughened for making construction joint. All walls outside forms have to be kept wet and top covered with polythene or wet Haitian because of quantity of concrete I just told you, which combination will release from this 50 cubic meter of concrete. Means if you just say 50 cubic meter of concrete means 300, say yes, 315, 6 into 9, 55 cubic. Let's say 50 cubic meter, let us say, and 300 bags, you can say 50 cubic meter. 300 bags means if you multiply 45 kilogram. Oh, sorry, so how much? Oh, yes, it is not too much, 15,000. It's big quantity, so you have to keep it cold. Calculate yourself. Maybe my calculation is wrong, I said 300 cubic meters, 55, 6, 350, 45, 10, 135, 13,500, 13.5 tons of carbon dioxide will be quantity used very dangerous one means you can suffocate that area internally as well. So you have to take out people also very quickly out from there, and then you have to keep whole area within limits of temperature, whatever way, or you have to shed that area. Means you have to apply some person immediately after that. Keep this clay okay, because already where it's hot. Then we can say make sure the top cold wall is roughened and all wall outside forms have to be kept wet and top covered because then or wet and check external forms as well as internal forms by strong hammer impact. Yeah, that's important. Check external forms as well as internal forms by strong hammer impact to find in case some voids do exist during application of vibrator. Though we apply vibrator, even then if you find some sound there, hollow sound, that must be though it's not there. Immediately should be done when you are vibrating. At that time, you are done. Then, if something is there, you can just apply vibrator and do that. Generally, when you apply vibrator, this won't be a problem. Make sure that repetition of forms would not require. So it's okay. There's no repetition of forms, so you can keep them in position for a few days because same shutting will go for upper one. So you can keep them 7-10 days until you reach that one. So it doesn't matter, you can wait for them. It's comfortable there, you are luxurious there in case of such nearly required striking. Do not allow removal of forms after 48 hours, no need at all in this case. And then whenever we will do that, but supports you can take out after 48 hours, doesn't matter, shutters will be there, but supports, props, etc. there, or even bolts and tie bolts you can take out, doesn't matter, because it is already set harder after 2 days, 3 days. And during a monitoring of forms, make sure that lines, that's already done after striking forms, make sure that defects are okay. Defects another point of view. This was my purpose here. So what I say is that this was a complicated code, and that was only reason I wanted to project to you. It's an important item because we do not feel on job that it's an important item, but we think when do it will find these problems. In this case also happened with me that there was a person, when I was doing this shutting, that person justify what you're doing. There's a question to me, you give me justification for your work you've done. Well, of course, he was a structural engineer. He was also a postgraduate, that Pakistani engineer, and he wanted to test me. No, he didn't say he wanted to test me, but he said because I want to ensure that whatever you have done is right. So give me calculation, your shuttering management, shutting arrangement, regist forces coming on this. So well, there's a fluid mechanics. You have understood fluid mechanics what it is, and this uses WHQ or 6. There's a moment here. Moment you have to calculate is square over 2, you have to calculate both vertical pressure is that and moment is that. Means this is what you have to check and calculate. Load, the 2.5 tons, and this. And you can also take the reduction factor because it's going to take say 5 to 6 hours to cast this. So in 1/3, when it's 1.5 hour, the second one is 1.5 hour. So you can say at this point when the release pressure is this, already we have used part pressure, partly 1.5 or set some. Well, we can say some application of 0.3% reduction in pressure, 0.25%, 0.25% introduction. So you can apply some coefficient if you want, just to justify in a better way. But ply 20 mm, then you have bolts, then you have that in per square meter. Movement is there and pressure is there on that system, and movement and pressure are justified that this system is safe for that, and which itself is justified by its tie bolts, because you are in 12 mm tie bolt, 16 mm possibly. If you take 16 mm tie bolt, it's quite big, means 16 mm is 2.01 centimeter square, and tie bolt is not ordinary steel, this is a high tension steel, which this gives you as much more better. So you can say what tension it can take and what moment it can couple is there. So you can very well justify this. Your question of writing a document, your bending moment, vertical force, the resultant force, you can justify your resistance. You are having ply, you are having tie bolt in that, you are having your timber scantlings, and you are having your vertical members of that, and then the supports you have in fact on top of that. Even if one side support is there, and then you have to support means you have props which can give 2 ton, 3 ton, and other side is 2 tons. So this is completely balanced, means it's not difficult during pouring what forces there. It can be justified, but a question of writing a document, doing some calculation, justifying, and you must know what stress timber can take, ply can take, and because this is ply is really, it's not so simple. This is a pressed one, and what your 2.2 into 3 inches, 15 to 75 scandling can take, and all that, the steel, you can justify that what force is there, what moment is there, what it gives, what is there. Man's whatever write, you write based on something. You judge just like in imagination. You know how much timber it is, and you know what steel it is. You know all that, and jack and all that is means you can assume. If it doesn't matter, means you can take 50% of that, even will work. As far as concrete pressure, as concrete and top level is this, the middle level is this, bottom level, right to 3 levels. 1/3 height is most important. 1/3 of the 4 meters height is 1.33. Means at second layer there's a pressure, third layer there's a pressure, first layer there's a pressure. So we can justify that one. And because some people try to examine you, because I used to talk to that man about something. He was, of course, and at that time actually we were working on our earthquake, our earthquake new coding, and that period was very complicated. But if you keep in touch with all the development, you know what ductility is, what is direct movement, what is that movement, what is ductile detailing, and if you just add steel and compression zone, what benefit you need. That's a problem in beam, etc. Means people don't understand design. If you use steel in compression zone, you can increase ductility. You can say your deflection control you can take into that. If you want to control deflection most important in design engineering. And if you can reduce deflection of beams or columns, half of your bugging is the half of your tension is finished. But people do not realize this fact. Do it practically. It works very well. If you provide steel in compression zone, you can make better use of concrete. You can keep it controlled from both sides, both ends. It can be practically done, but this is not told in theory. But you can use it. You can see it works in deflection controls, and when deflection is controlled to maximum extent, you are winner in that case. You can even reduce steel to some extent. Not necessary you comply with everything, because deflection is not going to harm you. You can apply you can say limit state of serviceability in a better way according to European codes. Don't worry about collapse load. Limit state of serviceability can be applied in a better way, and even if you apply further ultimate state, then you can go into the plastic zone of that curve, and use that material there until collapse condition reaches. It depends, but nobody is going to that limit serviceability stays welcome for me. I stop at that point. And with this I would say we should take rest now, and we'll talk later on. Already it's 4 hours over, and I think we should close it here now. And thank you very much, gentlemen, for next time we'll take this how you finish this. We'll take stair concrete pour, and then stair concrete pour. Then we'll take suspended slabs, and then pedestal footings, etc. And this is RCC footing blocks and generator. All that which is left we will take up. That's very important point here. But I'm happy to people are raising question. My friends raise questions. Very good for me as well as I will get prepared. If you have any question, you can raise it, or you can call on you can say, if you have what I say Skype, or you have even on this in this message, you can call video call during talk, no problem. And also Zoom, if you can arrange Zoom. I have downloaded that, but I have not started yet. If you can come on Zoom, well, it's up to you. If you can write here, no problem. Or during call, you can call. As far as work is concerned, it's great pleasure for everybody to know something. People would listen to you, and I think it works if you talk. Maybe I am wrong, or maybe I right. Maybe you're not satisfied, but participation and interaction works there. That's most important. Where participation works, everything works. And with this I close. They can leave. Thank you, gentlemen. And that's okay, fine.